Intrinsic species should be a lot of fun. We're going to create some creatures, and I hope that you have some fun with it. And I hope you take some time to explore and make your own like cool creatures. And we'll be using Mixamo, which just requires access to Mixamo.com. If none of you have ever been to Mixamo, we'll go over it, but you do need to make a free Adobe account if you haven't already to use Mixamo. So it'll ask you to sign in or join at Mixamo.com. Autodesk Maya, Rhino, I'll be using Rhino 7, but everything we're doing today should work in Rhino 6 as well. Grasshopper plugins, Pufferfish, Anemone, and Dendro. And then we have ZBrush and KeyShot. And yeah, it should be a lot of fun. Basically, before we get into it, the workflow is going to be that we'll basically be using Mixamo to get an animated character. We'll bring this character into Maya, and we'll go through the timeline of the animation and select a pose that we like. And we'll also do some minor sculpting if you like to change the shape of the character. And we'll just to find a pose that's something more than like the typical kind of A-frame or T-frame pose. That's how I got kind of like all these like weird, these weird poses. I was trying to find like, more like kind of creepy poses for some of them. So, and then we'll be, in Grasshopper, we'll be creating kind of particle systems with fields and Anemone, and then using Pufferfish to make these kind of discrete particle flows that stay within the character. And then we'll be using ZBrush to take those kind of pipes results and do different kind of smoothing effects to them. And then we'll be bringing it into ZBrush to render. So that's basically going to be kind of the workflow of the day. Nitesh, just follow the instructions from their PDF. They have very specific instructions for installing Dendro. One of the steps is about turning off COFF in Rhino, which is not a usual step for Grasshopper plugins. So you just got to follow their their PDF. Okay. So let me open up this. So I'm just gonna from now turn off my camera just so things are a bit smoother. So let me just turn my camera off here. Okay. All right. So again, let's get started here. And any questions you have, ask in the questions, and feel free to chat among yourselves in the chat. And also, make sure that you're following us and tagging us so we can see it. I want to see what kind of creatures you make, and also feel free to take just screenshots of this webinar and post them if you like, just so we can reshare it as well. Okay, so go to So what we should do is go to Mixamo.com. If you don't have an account, you'll be brought to a page that just asks you to sign in or join, and just go through that process of signing in or making an account. And once you do that, you'll be brought immediately to a page that looks like this if you've never used Mixamo before. And basically what that looks like is you have these two tabs. There's characters and animations. Okay, and you'll see here there's just like a bunch of silly animations going on here. The base character is usually this red character in like this base form, and this is the character I'm using for the webinar. If you want to use another character that's not like set up in this way, you can, but you'll just kind of have to interpret things maybe a bit differently depending on the character you choose. So the way Mixamo works is, did someone ask for the Dropbox again? Weird, I didn't see another message for the Dropbox. Anyway. So anyway, how it works is if you go to this characters tab, there's a bunch of characters you can choose from if you really wanted to change the character. I'm not going to change the character, but just click it, it'll change the character here in the preview. And that's, that's the character you'll have there. And then animations, actually before animations, there's also this upload character. If you have your own character that you've made somewhere, you can upload this character, and then Mixamo will try to auto rig it as well. So once you have this character, you can go through and just really just select an animation, right? So I just selected this Capoeira, whatever, Capoeira. I think that's like kind of karate or something. So once you have that pose, you'll get these sliders, and those are options you have within those sliders. You can change like arm spacing, overdrive. You can make this, if you want to make him, him or her go faster or slower. But really, we're not going to use actually the animation. We're just looking for an animation that could give us potential for some interesting poses. And I think actually, you can search up here for like different animation keywords. I think I was using the robot. Right. So I was using this one to get my poses. So you can get some kind of weird, like dangly, like hanging poses from that. But you can try other words too, whatever you want your pose to be. You can get like a creepy, pose, or like even creepier, right? So choose the one you want. I think I'll go with the robots. It was fun to work with that one. So I'm just going to select the robot. So did everyone have Mixamo on the and understand it? It's so easy to use. I mean, it's just basically a big library of automatic animations that Adobe has made available. Okay, everyone's good from that point. So once you have something you like this, all you're going to do is you're basically just going to download, right? And what we're going to download is we're going to download FBX, and frames per second. It doesn't matter again, like because we just want like the animation to use a frame, so don't specifically care so much about the animation. But FBX is what we're going to need for bringing it to Maya, bringing the animation into Maya. So I'm just going to download that, and it's going to preparing download, and it's going to download that. So it's going to download an FBX. You see it went down there. So if I go to my downloads folder here, so if you go to your downloads, you'll have that FBX, right? So I'm just going to put that real quick in that Dropbox. If anyone's for some reason having issues with Mixamo, I'm just going to put that in the Mixamo folder in the Dropbox there. Okay, so once we have that, you can close Mixamo. You don't really need it open anymore. So I'm just going to close this. Just browser. So next thing you're going to do is you're going to open up Maya. Okay, so I have Maya opened here. And this is the Maya file in the Dropbox, so it's just empty for now. But when I save, you can, of course, just download it if you like. So what you're gonna do is you can file import, but I'm like a big like drag drop kind of person. So you can just take the FBX and just like drop it right in, and you'll see it's loading, and you can see my timeline. If you caught it, it was kind of like loading up there. So if anyone doesn't know Maya, use the wheel, scroll wheel to zoom in and out. Use Alt and then hold down middle button to pan, and Alt and left mouse click to rotate. Okay, so you'll see we have this animation in here now. And if I go down here to this play button and click play, you'll see that. Now you'll notice mine is moving in real time. You might have, and that's just because I've changed something actually. So I'm going to show you how to change that, because it probably looks really fast for you if this is your first time. So if you go to Windows here, Windows, and then Settings, Preferences. So that's Windows, Setting Preferences, and then you scroll down here to Settings and then Time Slider. You'll see here there's playback speed. It's default like play every frame, and that basically just tells your computer like play this thing as fast as the processor can handle, which is kind of just like not really. I mean, you could just like scrub through it by clicking down here in the timeline and like scrubbing through it. But if you just want to like look at the animation, like it's kind of hard to see. So what I did was I just went again to the same place, just Windows, Setting Preferences, Settings, Time Slider, and I just set it to frames per second x1. So it's just like the actual frames per second speed. So save that, and now it should be like, you know, the regular kind of speed that it was for the most part in Mixamo, despite any lag you might have depending on the computer you're using. Yeah, so it's a lot of fun to see this dance. I'm interested to see if you all pick robot or if you all pick kind of weird other creepy ones. Has anyone used Mixamo before, or is this a lot of your first time, like just even knowing that Mixamo exists? Feel free to write yes or no or whatever in the chat there. Yeah, Mixamo is just really cool because it's nice. It's on the browser. You don't have to install anything. It's free. So anyway, what I do is like I pause, you know, just like, you know, pause the animation, and you can just scrub through it and try to find like a pose that looks interesting to you to use. You know, I think this is like one of the creepy poses I used, right? Like it's kind of just like weird looking. If you want like a more regular or like the kind of zombie pose, which is also kind of cool too. And yeah, so I'm just gonna select a pose. I'm not exactly sure which one I'm gonna use yet. I don't know, maybe like maybe I'll go with something like that. That's kind of interesting. So once you've selected a pose, what you can do now is if you see in this like top like tinier menu here, there's this like box which is called wireframe on shaded. So I'm just going to click that just because I want to see the wireframe. Now, even though this is a pose character, you can still model it. It does not like mesh inside. Yeah, you have to have pretty clean meshes and pretty optimized meshes to upload a character to Mixamo. Like you can see, this is a pretty optimized character. But you can also just download the rig from Mixamo and then attach, your character in Maya or Houdini or whatever. So, okay, so now that we have those on, if you don't know Maya, all you do is you just right click, you just select. So you can select the mesh. In this case, the mesh is in two different parts. So I'll just select this kind of body-ish mesh. And you can hold down right click and you get this kind of menu, this kind of spider menu. And you just let go of the menu on the kind of thing that you want to use. So in this case, I'm just going to go to faces. Right. And let me just turn it off. Right. So that's going to let you start to select faces. So what you can do now is you can start to sculpt if you want. So you just select faces, and it's a little hard to see because there's a kind of loss there. And then there's W, E, and R. That's move, rotate, and scale. And in this case, we just press W to move, and you can move, with these arrows. Okay. Now, actually, for you, it might be like this. Well, actually, I think because it's attached to the character, it's going to go in the normals anyway. But to make sure, you can just, if you go here to Modeling Toolkit, to move settings will be like the orientation. You can set it to component. Right. So now, well, not in this case, not in the case of the head, no. It gets a little bit weird with these rigged characters. Now my character's head is like just permanently dented in. So yeah, it gets a little bit weird when you're working with these kind of animated characters. Get back to my pose. Okay, yeah, it's like something like that. Okay, back to what we were doing. You can press F to like focus on the character there. So I'll go back to object then. Face. So the blue arrow is going to go like in the normal direction. Okay. Now, if you select faces like this, and then back to where it originally was, something like that. Okay, so if you select faces and then hold down, press B, and then the middle mouse button. Is it necessary to bake? You don't have to bake if you don't want to. Because if you bake it, you won't be able to animate it anymore. So up to you. So if you hold down B and then middle mouse button, so B plus middle mouse button, and then drag the mouse over, you'll see you get this kind of like expanding circle. So that's going to be like the soft selection. So you get something like that, and then you can start to sculpt. Like I don't know, maybe you wanted like a big kind of alien head or something like that. So what's nice is, if you sculpt and change the shape of this thing, you can still animate it if you wanted to. Like it's still all attached if you wanted to change the pose. And now it looks like one of those kind of, it looks like the xenomorph. It looks like the ones from like the Prometheus, like those kind of lower level ones there. So let's get my, some pose like this back or something. And we can, you can go ahead and you can really change whatever you want. I think I'll just mess with the head, but it's up to you. You could like give it like a big back or something. Leave it to you to play with that. Stranger Thing. Yeah, the Stranger Things. Yeah. So the other thing is you can work with symmetry too. You see, I'm only selecting half here, like, and not the other half. So if you go to the modeling toolkit again, you'll see that there's this symmetry mode. Now it's not going to be able to find the symmetry because your object isn't symmetrical anymore because it's animated, right? Like, so there's no symmetry there. So what you can do is, in this case, you can go to symmetry and you go to topology. And when you do that, it's going to ask you to select a mesh edge that represents the symmetry, right? So I'm going to select this edge like right in the middle of the face. Let me turn B. If you press B, it'll turn off and on, like smooth selection. I'm going to turn it off so you can see, and then I'm just going to select an edge right in the middle of this face, right? So now you see that it's got a symmetry now, right? So we can press B again to go back into that mode, and then you could, change this as well, right? So it's going to work in a kind of symmetrical way. And I think if you see if it looks like it's doing that, then you just have to mess with the like when I try to go this direction, see how they're kind of like going opposite. They're not exactly following correctly. That's when you can go to, like, for instance, in move settings, you can go to let's say component. It just gets a little bit tricky sometimes with the animations, but maybe I'll just go back to parent. So parent works, it seems, in this case. So something like that is fine. And then I'm just going to right click and go back to object mode, hold down right click, go back to object mode, and that will like exit the plan. So now I have something that's like looking like this. You don't need to go into 3 mode. If anyone doesn't know, 3 mode basically means that the mesh will be smooth, a smooth preview. So if I click this and press 3 and give it a second, you'll see that everything kind of like rounded out. But we don't care about that because we're not working at like that level of detail. Say no enough. Yeah, just you'll get the recording. So like as we mentioned in emails and everything else on the website, it'll be emailed to you. So the problem is if you're in smooth mode and you play, it's gonna, okay, in this case it's like pretty fast actually still. Sometimes in smooth modes, like animation can get a bit slow. So pause it. I'm gonna just scrub back to like somewhere around the thing I was doing, something like that. Okay, but I'm gonna just press 1 now, just so we can. I'll zoom in here. I'm just gonna press 1. Sorry, select the mesh and press 1. So we go back into this resolution. Okay. So once you have something you like, all you have to do is then we want to have these 2 things separate, which is in this case, and again, it depends like the model you're using, but in this case, there's basically 2 things, right? There's the skeleton, which you can see here underneath, but we don't really care about we're not going to be using the skeleton. I mean, I was looking for a way to export the skeleton as geometry, but I couldn't find a way. So if anyone does know a way to do that, I couldn't find a way to do that. But I only can export it as a rake, which is the usual case, but I thought it would be interesting to also be able to export the representation of it as a geometry. So what I'm going to do is I'm going to select this kind of main mesh here, and you're just going to go like File, Export Selection, and make sure your file type. We're going to do OBJs for Rhino, right? So exports OBJ. So get OBJ, and we'll just go to. Oh, you can export it anywhere. For instance, you can just do it on the desktop. And I'm just going to name this one like body exports. And then I'm going to do the same here. I'm just going to select these spheres and do the same thing, export selection, and we're going to name that. I'm going to do it again like desktop or any folder, and joints. So body and joints seems to make sense to me. So once you have that, and actually I should have put that in here. I'll put that in the Mixamo folder. Actually, that will make it easier. So I'm just going to drag those, which exported. You can keep the material if you want this color to come in Rhino. If not, it'll just come in gray, up to you. So you have body and joints. Okay. So that's what we'll be bringing into Rhino. Why don't we take like 5 minutes so you can like just play with the character, just mess around with the mesh for 5 minutes, and we'll come back and then move on to the Rhino stuff. So yeah, just take a few minutes, find an animation you like, bring it in, scrub around the animation. Isn't there any way to export full model of a single object file with different geometry organizing layers all at once? I don't know. It's only 2 layers, so I don't really see why you need to go through all that. So yeah, so I'll see you guys all. See you back in about five or so minutes. Until then, play. Yes, there's always a recording. There'll never not be a recording. It will always be emailed to you. Yes. Don't worry about the recording. Let's try to focus on what we're doing at the moment. Okay, so there you go. Let's be back in 5 minutes. Okay, I'm back. Hope you're all having fun doing some characters. Seems frozen. No, it's not. It wasn't frozen. Okay, so we're back, and we have our character that we made, and so now what we're going to do is I'm going to open Rhino. Here. We don't need Grasshopper yet. Okay. Do we have to stay for the whole webinar? Yes, you have to stay for the whole entire webinar, and you're not ever allowed to leave ever. Yes, you can leave if you want. They'll be recording. Don't worry about it. Is it better to always export over J for all? No, don't use IGES. We're using meshes. IGES is surface data. We don't need surfaces for this. Okay, so now we're in Rhino. If anyone's not used Rhino before, again, the wheel is to zoom in and out. In this case, the right mouse button is to orbit, and pan should be pressing down middle mouse button. I think. I'm not sure because I might have changed some buttons, so I don't remember. This Rhino file is, can we all upload a picture of character we edited? Do you mean upload into Zoom? I think there's a files thing. I'm not sure how that works. But you can certainly put it on Instagram and tag us. We'll reshare it. But if you want to put it here, I think there's a files button. At least I have one. I don't know if it has one for you. There's like a little thing there. A little like folded paper icon. So this file, this here is the file from Dropbox. So if you want to download it, you can. It already has these layers, or you can just make these layers. I just have these layers just to keep things organized for myself. So I'm going to just double click here on the bodies layer, and I'm going to just drag and drop our body. So our body OBJ, I'm just going to drag and drop that in. We're going to do import file. Okay. We're going to do map OBJY to Rhino Z because Maya has the Y direction as up. And that's basically all you need to do. And so you just import it. And once you import something, it might be off screen like this. You can just select this like little yellow icon here, and you'll have be zoomed into it there. Okay. So once we're in Rhino, it's not animated anymore, right? Like we're just bringing in the static pose. We don't need the whole animation thing. And I don't think Rhino even has. If it does, I've never played with it. Like, I don't know if it can bring in animation like that, but I never did animation in Rhino. So, and then the same for the joints. So I'm just going to go here to the joints layer, just because I want to have things organized. So if you see, if I turn body on and off, alrighty. So go to joints, and just drag the joints in, import, same settings. And now you have your joints. Okay. So first things first is if you see when I select these, it's reading it all as like one mesh, and same with this. So there's like two meshes there. But we want to split those up so that we can deal with them easier. So to do that, you just do just type in the command line split disjoint mesh, right? So basically what that does is it just looks at all the parts that aren't connected and makes them their own mesh object, because you can have entire meshes, even though they're not connected, read as one object. So just press enter, and now you can see I can select all the body parts individually. Okay, and we're going to do the same for the spheres. So you can just hit enter to run the same command again. Select meshes, we'll select the joints and do that again. So now we have the joints separate as well. Okay, so that's the first thing, is to get those separated. Now, what I'm going to do is I'm going to hide the the body for now, and just have these joints. Okay, that's basically the joints of this animation. Looks a little funny. So we need to create some bones, and the bones are basically, and that's why I was thinking about, like, could I just take the rig as pure geometry from Maya? But I just couldn't find a way to do it. Because the rig in Maya is, I mean, it's represented as like geometry so you can see it, but it's not actually geometry. So what I do first is I get the center of all these spheres, right? And unfortunately, so you can use an area centroid to get the center of spheres, but you can't do them all at once because it gives you like a center, like like a general center. Like it'll basically be like this point here, like the center of all of them. It doesn't have an option to like treat them individually. So we just do them one by one. So I'm going to go to my centers layer, and I'm going to go here in perspective. I'm going to go to, I think if you open a new file, it was on wireframe, and I went to shaded. In the file I saved, it's saved as shaded. So I'm just going to go to wireframe just so I can see through it. And you're going to just type area centroid. So this area centroid. And you're just going to click an object and hit enter. And it's going to give you like the center point of that object. So you're just going to go through and select each one of these and hit, so just enter, select, enter, enter, select, enter. And we're just going to get the center of all these spheres. And the reason we need these bones is because, so these are going to be the points, and then we're going to connect them with lines to what I'm saying is like the bones. It's kind of like our line-based rig, if you will, is going to be where like particles are going to emit from. Because the more central you can emit particles from, the more space filling it will be. If you just try to emit from like the skin, all the particles are going to just stay on the skin, and it's going to feel very hollow. You're not going to have that kind of solid build feel to it. So we got to create these bones to emit particles or generate particles from. That's where they'll start from. So, you know, just go through. It doesn't take too long. It's not so complex. So, you know, sometimes you just got to do things manually. So now you have that. Then I'm going to go to my bones layer here, and I'm just going to turn off the joints. You could turn them on and off as a reference, and you're just going to like connect with lines. So I'm just going to come here to the polyline, or you can use line tool. Select it, and then just like connect the points as if you were drawing a skeleton. And they don't even need to connect. Like for instance, for the shoulders, I was doing something like this, right? And then from like for instance, the neck to the torso, or something like that. And you can see that they don't touch, but it's okay. It doesn't matter for what we need them for. The kind of bone structure is just like a general center of mass, like that will generate particles from those lines. Okay, so start to just trace out. You know, I'm just going to trace it out. You can start to see like there's the hand. And I'm doing it like you see I'm exiting the command each time. I found that for some reason, like using lines instead of a full polyline was giving me better distribution of the particles. So that's why I'm doing that. And I don't know what that is there. it's just a wrong connection. So that's why I'm like exiting the command. I'm basically just drawing lines instead of doing like that, you know. I just found that it was working better for like the point distribution in the beginning. So a little bit of manual setup, never hurt anyone. So, and thankfully it's not too complex. And again, I connected the wrong thing there, so I'm just gonna delete that. It should go from here to here, right? And then the torso is going down to like pelvis area, to hips, to knees, ankle, toe, toe. So you end up with something like this, right? So you can see that's kind of like the skeleton there. Right? So the other thing is that's not enough yet, because we have like this whole head here that we want to get into. And if you had any other features, you know, that you wanted to get into. But in this case, we have the head. So the first thing I do is I go from like the neck to like the top of the head. Something like that. And again, this stuff doesn't have to be so precise. It just needs to get the in there centered. Now, the one I did for the promo, I didn't have this long back part of the head, so I was just going straight up. But since we have this, we want to make sure that particles generate back there, so that, you know, our kind of swarm, you know, fills this area more. So what I'm going to do is I'm going to draw one from like the front of the face to like the back of this thing. So I have like something going like that. And you might want to get something, you know, going up into those, if this is the case, like into those horns. And again, don't worry about being precise. It's general. We're just doing general things here, right? So something like that. And I might even want to come across the head, like just to make sure that I fill the head. So I'm just going to do something like that, right? Something just like crossing the head. Okay. And for the torso, since this torso is a bit like, for the arms, it doesn't matter because they're like pretty proportional in all directions. The torso is a bit thicker in this direction. So I think I want to also, let me just turn off the joints. I think I also want to make something going through the torso a bit. All right. So I'm just going to grab, I don't know, something like from the front here to the back here. And you can always change this afterwards. Like once we run the simulation and you're like, oh, it's not really feeling as much as I'd like in a specific area, you can go through and add, you know, add some of your kind of what we're calling bone there to just make sure that it is. So at the end of the day, you should be left with something that's looking something like this. Okay. So let me save this. I'm going to save as a 6 file in case any of you are using Rhino 6. Just override it in the Dropbox there. So now if you took it from Dropbox, you'll be at the same point that I'm at. Okay. So is that clear to anyone? Anyone have questions about that, or why we did that? Just let me know. No? Okay. Seems good. Seems good. Okay. So the next part of this that we need for like just the overall model, why did you connect it from the head? Yeah, so I mean, these things will make more sense once we get the simulation running, but basically we're going to generate particles, and those particles are going to be in this body, and those particles are going to start or emit along these curves. So the reason I did that is because these particles are going to have spin forces, and if I started just at here, and there's a spin force, the particles might end up spinning just around here, and they might not find their way back there. So all we're doing is we're just forcing particles to also start back there, so that we make sure that it's more filled out in some of those harder to reach areas that, you know, a particle generated like in the middle here might not reach over there. So we're just basically forcing it to have to start particles over there as well. Oh, wait, export full model for my check. Creeper, you asked that already. Maybe just copy paste it, but yeah, I don't know. Because Rhino is not not really necessarily an animation tool, so I'm not sure. I don't know what layers this was on, because again, I just downloaded it from Mixamo. I want to use my own layers though, so it's just easier for me to understand. Okay, so now that we've done that, first thing we need to do before getting too much into Grasshopper is a Grasshopper step, which is Grasshopper and let me, before I reposition this thing. And I think I may have left this out because I tend to forget that Weaverbird is a plugin. But you should have Weaverbird if you don't already. Here. So I think just Weaverbird. Yeah, Weaverbird. Okay, just put this here. So sorry for leaving that out. So you just download Weaverbird 6 and 7, and that will give you a GH file, and you just open that GH file and it will install Weaverbird for you. It's just such a common plugin that I get that you have to install it half the time. So I'm going to get a mesh container, mesh parameter. If you just double click in Grasshopper, you can search things, right? That's the way I work. You can also find in the tabs here, but honestly, at this point of using Grasshopper for like 12 years, I don't even remember where things are in these tabs. I just remember like what I need and I just search for it. But this is in parameters, geometry, it should be here somewhere, mesh. Yeah, mesh. A single object blender that came out of separate groups perfectly. That's great for you, but you would still have to. Again, the reason I did it not separate is, first of all, it's only 2 things, so it's really not a major issue. Secondly, is I want to use my own layers system. I don't know what Mixamo names things or how it organizes them, so I just want to use my own thing. If you want to do it however you want to do it, go for it. It doesn't really change anything, so yeah, do whatever you want to. If you want to bring it in that way, bring it in that way. So what I'm going to do is I'm going to get the body, and this is just going to be for like when we're doing the rendering. If you remember from my promo, there's kind of like this glossy body around everything. And that's, so basically we're just going to make a really smooth version of the body so that we can get this nice glassy kind of shell. So I'm going to select all the bodies. So select objects and set multiple meshes, get all the meshes in there. And then I'm just going to go to, in Weaverbird, it's called Path Mall Clark. Right. And we're just going to subdivide it to 3. It might take a second. So add the body, maybe off. So if you see here, I have this layer I made called Body HD. So that's like high definition body. So I'm just going to bake it there. To bake it, you just click the component, click down the middle mouse button, and you can just click the egg there. It'll bake onto the layer you have selected. This is also now in that thing, right? So if you look at the mesh, it's a lot denser of a mesh, but it's going to be a lot smoother. If I, for instance, go here to Arctic mode, you can see it's like very smooth. Thing. If I go to body, you can see how it's like kind of rougher, especially when I zoom in versus like the HD body. And that's going to give us, that's we only need that part for KeyShot. That's just going to give us like really nice smooth reflections. So I just want to just make that right off the bat, get it out of the way. But for everything we're doing Grasshopper, we're going to use just the regular body. Okay, so let me just do file and save as. I have to do save as to do Rhino 6, so that's why I can't just like Control S as I usually do, just because I have a suspicion that some of you are maybe not using Rhino 7. And you'll see it'll take a bit longer to save because that HD body that we have there now. And probably the file size is bigger now. If I go here, let's see, Rhino. Yeah, see, it's a bigger file now. But we need that body if we want good renderings. So, and I don't think any of you want bad renderings. Okay, so we have that. Now we'll get into like Grasshopper stuff. So let me just reposition my windows real quick. So is everyone is good so far? You've got some character there in Rhino, or you've at least downloaded my character that I'm working on now. And were you able to get Weaverbird? Okay, nothing, no comments. So I guess I'm just going to assume you're all good. It's a fun, to me, this is a fun workflow. I like workflows where I get to, play back and forth with a lot of different softwares and techniques. When you export the cat file, in which format was it? I didn't export the cat file yet. I just baked it. So I don't know if you can clarify what you mean by exported catmol. All right, so okay, yeah. We didn't export it yet. We'll export it when we get to KeyShot, where we can get Weaverbird. Sure, here it's in the chat, but I'll put. That was my mistake. I mean, the Weaverbird is like probably the first plugin for Grasshopper ever, and I just get so used to it. I'm surprised it's just not a part of Grasshopper already on its own, like the way Kangaroo is. It should be because it's very useful. Okay, so we're gonna get two mesh containers. Just because I like, for organization's sake, to have the body and the bones, body and the joints in two different containers, even though we're going to join them together anyway. It just, for clarification, just seems easier. And I'm just going to name it like body. I'm using this bifocals, which names everything for you. So sometimes when it's a single component, it hides like things. So I'm just gonna go to blob. If you right click like an outline, by the way, if anyone doesn't know, um, you can just select it and then just do Control G to like highlight it. And then if you right click it, you can change like color and all that, but you can still change the size, right? So you right click and go to blob just so it's bigger, so I see that it says body on the top. And here, right click and blob. And I'm going to name it joints. Okay. And so in here, we're going to set our body meshes here at joints. So we're just going to go here in Rhino, right click on the layer body, select objects, and it's going to select all the body, and then right click here and set multiple meshes. And now all your body is there. So we can hide the body here, and you can see it's here. Same for joints. So I'm just going to select joints. I'm going to right click, select objects, and right click here, set multiple meshes, and now your joints should be in there as well. So I'll just hide the joints. We can also hide these centers. We don't need to see them anymore. And first thing we're going to do is we're just going to join those together. We could have set them all in one, but I just like them separate for clarity's sake in this case. So we're just going to join mesh. And we're just going to plug everything in there. If you don't know how to do that, again, if you're new to Grasshopper, if you don't know how to do anything, just let me know, because I've just been using Grasshopper so long, I forget like what's basic, what's not. And that's why we have like the references on our website. So just do shift and then drag, and you'll be able to plug multiple wires. So you get this like little green, there's a little plus sign next to that, and it turns green. So they're basically, we just join them together into one mesh. Now when I select it, they're one. Now join just means they read as one object. It didn't actually do any kind of like Booleaning or anything like that. You can see they're still through each other. It's just that they're one mesh now. They read as one mesh object. And I also like to use mesh containers as a way of organization for when I want to, like, if I wanted to plug and play different things in. So, and I'm just going to highlight groups as I go along with them, just like as we do different tasks. I'm just going to highlight them together. So I'm just going to say that this is like save behind. So now we have this, and if you select the stuff after, and then just middle mouse, and you can see this blindfold, right? You can just turn all that stuff off. So we just have the one thing here previewing. And so in the next section, so for the next section, I'm just going to get a mesh again. Right? So this is what I'm saying. Like, I just like to do this kind of like container to container, and it's like if I wanted to replace this with something else, like I don't know, say I had another one of these, I can easily like replace a part of the definition with something else. That's just habits, even though in this case we're just doing this one thing. So now we're going to just get this all to be one object so that we can effectively move particles around it. And for that, what we're going to use Dendro for. So Dendro is here. And I guess, unfortunately, it doesn't work in Mac, which I didn't know. I don't use Mac, so I can never really tell. So there's this thing here called convert, right, in this tab. And what we want is the mesh to volume. Right, so we're going to plug that in. And we need settings. We need to know how to convert that thing. So again, in convert, there's create settings. Now, the important thing is there's two sets of settings here. And I always say this when I teach Dendro, is this component, in my opinion, should be split in half, because these two actually only control mesh to volume, whereas when we, after we go mesh to volume, we want to go back to mesh, because volumes are going to perform actions of us, but after you make the volume, you can't actually use the volume anywhere else in Grasshopper. You need to go back to a mesh, right? So what we're going to do is volume to mesh after we create a volume. And if you don't understand what volume is, you'll see in a minute. But so we're going to go volume to mesh after that. And it's actually then these two settings are actually working for this, right? So I'll draw those arrows a bit clearer, but really this component is two components combined into one, which can be a bit confusing. So the settings that we want to use, I'm just going to do them because I know them off the bat of like what I used, and then I'll explain them, because using the wrong values in settings with volumes could potentially make things like freeze on your computer. So before I plug anything in, I'm just going to get the settings that I used for for the one I was making, and then I'll explain kind of what that's doing. So I know that I was using 0.5 for the voxel size. I was using 25 for the bands. And then for the ISO value, when we go back to mesh, I was using 0.0002. And I'm going to actually group these. I'm going to write actually what they're controlling. So this is mesh to volume. And then adaptivity here, I was using something 0.113. That, and I'm just going to say that this one is for volume to mesh. All right, and then just plug this settings in and plug this setting in, right? And now let's okay, and I just want to reiterate that, I'm just going to draw these arrows for you, that these settings are controlling this, and these settings are controlling this. Okay. So let me just group that, and we're just going to say, creating single volume mesh. Save. So I can preview this off. Let's start here, right? Okay, so if we go to mesh to volume here, right? If you look at the output here, it's actually creating a special kind of thing, which is Dendro volume. So once you're in the language, we're not doing any of it here, but once you're in the Dendro volume world, you can then play with all of the Dendro things here, like offsetting, smoothing, blending, whatever. And then after you're done doing all the kind of Dendro-y things, you're going back to mesh, right? So then this is mesh, and that's a geometry that Grasshopper understands for other things that we want to do down the line. Would be nice to know what is the size of the model. So the model is from what do you call it, Mixamo, should be accurate in millimeters. Yeah, I mean, that's 176 millimeters. Seems correct to me. Okay, yeah, I'm working in millimeters, if I didn't mention that before. So basically, what's going on here? First of all, if you look at the model, you'll see we don't have those overlaps anymore. It basically like smoothed everything together. It's like a voxel-based Boolean, let's say, if you will. And that's why you have this voxel size. And in this case of what we're doing, we don't need such a refined mesh. So you can see like here, like the fingers kind of blended together. We don't need really every single finger individualized for the case of what we're doing. But if you wanted to, and I don't want to do now because the more, the finer resolution of things, the longer things take on your computer. And I don't feel like waiting around. And I have a suspicion you don't feel like watching my computer compute rather than us just doing things. So voxel size, and then you have bandwidth, right? So bandwidth is like how many bands outside that will exist so that you can do things. How to change pose of avatar. Yeah. Hey Alejandro, that was like the first part. You do that with Mixamo and with Maya. So you bring the Mixamo model into Maya, and then it's animated, and then you can select the pose you want to use in Rhino. Yeah, so just download animation, and then you can just bring it in here. Yeah, it's pretty simple. I mean, just go to Mixamo, download the one you want, and bring it into Maya, and then just select it from Maya. Like, just select the frame you want, and then just export it and import it to Rhino. So what does that mean? We're not going too much into VDBs. We're just using them for this specific part here. But what it means is if I have a mesh, like let's just say an arm and that shoulder ball like that, right? Basically what this means is it's gonna fill this space with voxels. So that's what the voxel size is. So if I have 0.5 voxels, like let's look at this condition here, it's basically gonna fill this, like it's gonna approximate it with a grid of like voxels that are the size of like 0.5, 0.5, 0.5. So it's just gonna try to fill this geometry best it can. Right, I'm not gonna draw this whole thing, but so you get the idea. It's just gonna basically approximate the geometry with voxels. Okay, bandwidth. What bandwidth means is how many voxels exterior and interior to the shell do those voxels go. So for instance, these voxels, this kind of layer here, the one that's closely following the mesh, is kind of like, let's say, the center of voxels. So any voxels coming out and then voxels going in like this, right? That's going to be the bandwidth. So if your bandwidth was set to 1, all you would have be generating behind the scenes is a band of voxels in that direction. Now, if you had this set to 2, you'd be generating another band, right? So you're generating another band. Right, so that would be 2 and 2. In this case, we went to like 25, which is probably not even necessary in this case, but so it's going to do that 25. In this case, it can only go to 2, so it would stop, and then bands would kind of go on the outside or whatever. pose automatically when we change the pose when we move to 5-frame? Or is there a way to fur them directly? Not that I know of. Again, I don't use animations in Rhino, so I don't. I mean, and Rhino is not really a character rigging tool, so maybe, but I don't think so. I'm not sure. So that's why I do it in Maya and just bring the pose into Rhino. Okay, and so that's what that's doing. And what that does is, like, for instance, you have here these tools, like, for instance, offset volume. So, like, if you wanted to offset this volume by a distance, I don't know what the distance would be. Just like this. So if I offset that volume by like something like 10, basically what's going to happen is you see how it's basically went 10 bands outwards, right? So now you got like this fat character here. Right? I'm not using that, but you can play with that if you like. And you can see when they begin to touch, whatever. Right? So that basically is the distance that you're going, and it's using these bands to get to that distance. So if I had this only set to like 2 bands of 0.5, then the maximum I would be able to offset is 1, right? Because it's like 0.5, 0.5. So if I had this set to 2, this 10 wouldn't work because we haven't generated enough bands behind the scene to be able to do that offset. That's basically all that's doing. So that's how bands and voxel size works. And then voxels to volume to mesh is you have kind of ISO value. So the ISO value is basically like the resolution of the mesh, right? It's just doing a calculation, and you can read about it here about crossing point of volumes that is considered the surface. So it's just going to it's basically the resolution of the mesh. Let's say we want like a higher resolution, so we're kind of closer to the volume, and then you have accuracy. Sorry, adaptivity. So adaptivity means it's saying like, are you going to allow variation in the polygons or less variation in the polygons? So the higher adaptivities will allow more variation. So I'm just putting low so that like the polygons are for the most part more uniform. Let's say. So that's how that works. So if you were ever wondering, that's how VDBs work in a nutshell. And you can search them online. It's a big part of what Houdini is doing, and it's using the same thing. So if you ever want to look this up, that's what it's called, OpenVDB. It's made by DreamWorks, I believe. So yeah. Why can't we work in Mesh itself? Well, I mean, how are you going to get to this point where there's no intersections? It's a single body with no intersections. Everything is one mesh. You need one single mesh. So if you can find another way to do that, maybe with booleans, but booleans kind of are pretty junky and take a long time. So yeah. Versus here, where if you were to use the body and the joints, everything's intersecting themselves. And I go to wireframe here, everything's like, they're not one mesh. So, whereas here, it's one mesh. There's no more things intersecting themselves. Okay, so we're here at this. So the next thing we want to do is like pretty much the same exact thing, but we want to make a skeleton. We want to make the skeleton solid so that we're emitting points off of a mesh. Because we're going to like randomly but evenly distribute points along the skeleton. And the best way to do that is with a cylindrical object that has some dimension. So we'll just make like a thin, we'll basically make a thin mesh for those. So, and I actually just realized I want to make, just turn this pretty off. And let me get my usual mesh here. Mesh. Add that to the group. So creating single volume mesh. And then I actually realized I want one more connection across the body because I see the body's a bit wide. So I'm just gonna go back to my bones. And I'm just gonna draw some kind of line across here to up to this area here. Again, it doesn't have to be terribly accurate, so something like that. Something like that is good. Okay. So let me turn off the body. So now we have this kind of skeleton that we've made. And we're going to basically do the same thing we did here, but we're going to use a pipe instead. So first things first is to get a curve container. And we're going to select all the skeletons, the bones. So select objects, and then here, set multiple. I only did set one. Select object. Select objects, and then here, set multiple curves. And then we're going to use in Pufferfish, there's the parameter mesh pipe, or parameter pipe mesh. It has a lot of options. We're not going to use really any of them. We're just going to use like the basic default stuff. So it's just going to create this for now, like simple skeleton like that by default of what it's set to. That's good enough for what we need it for. If you want to go more in depth on any of these components in Pufferfish, there's a lot of example files in the Pufferfish examples. Check those out. But the point of this is like, I just need a mesh. I just need a pipe mesh real quick. I don't need to do anything fancy with it. And we can create a thickness. Thickness just will determine like how close that is. Like we don't want to go too thick. But we can go, I don't know, something like 0.5, like closer to the center, the better. But obviously you don't want 0 because you want points to be able to propagate like around it so that you can go in different directions, basically using the mesh as a way to orient the starting of the points. And for the purposes of then using Dendro just to make this like a solid skeleton, because you can see now, you can see they're all like different joints separated. First, we're going to cap. So which is like here, you see there's like this end caps option. And we're just going to use, we can use a round cap. So what 2, we just set this maximum to 2. Right, so that just caps the ends there, like they're not open anymore. But you see we have, again, all these intersections, which we'll just get rid of with Dendro. Hands already look spooky, creepy skeleton mesh hands. So now we're just going to do exactly this again. So you can actually just copy all of this above with the same settings and everything and bring it down here. And then just replace this into here. And our result will be Let me just label these things real quick too. Wow. So this is going to be the bones. Match pipes. Hide that. So you can see now how the hands got, right? Like, but again, we don't care so much about the resolution. We just need like a solid object. We don't care if it's bumpy or wavy or whatever. Just emitting points. But you can see things like this like got smoothed together and stuff. I think the hands even look more creepy now. Okay, so you have those two together. And I'm going to do my usual kind of connection thing here, just for organization. I'll just bring this up. Or our next phase here. And let me save this because I think I made a few changes here as we were working, in case anyone needs to catch up. So has everyone got to this point that is following along? Cool. Okay, so the next thing we're gonna do is we're gonna define before getting into like Anemone, we're gonna define forces for our kind of random set of forces for our field to use. So what we'll be doing now is we'll be going into the what do you call the like playing with like the field components a bit. So first thing we need is points. So we're gonna get populate geometry, and we're gonna be populating the skeleton with geometry. Right? So and also now that this is a singular mesh, what's nice is that like the populate geometry has kind of like an even distribution kind of algorithm in it, which makes it a lot easier to get. So it's kind of like populating geometry randomly, but also trying to spread itself out like pretty uniformly, right, for the most part. And we'll get a slider for a number of points. I'm just going to go to 100 for now, just to see what happens. This over. Okay. Number of points. And we can play with the seed too. Seed is just going to change, like, it's just a random value. So it's just going to change randomization. So as you see, if I change this, it's always this many points, but this is just like the randomization factor. So you can just like pick some number and go with it. And you'll be able to change that too as well. So we're going to make some spin forces basically. So if we get the spin force, and if I go into vector field, you'll find all the field components and you'll see that there's spin force. Okay. And what a spin force is like basically you're creating like like a vector object that's almost like a whirlpool, let's say. And so like your particles are gonna like get caught up in that thing and do like, depending on the values you set, traveling along those things. So we need a few things. First is we need a plane that defines the orientation of the spin force, right? If I just use XY, for instance, and just, if you want to find something, you can just click it, hit the middle mouse button, and then zoom to it. So you'll see there's like a default spin force, and it even has like the arrows that show like the direction it's going in. But we wanted to find these things in like random different orientations throughout this body. So what we're gonna do is we're gonna create a plane for each point, and we're gonna rotate that plane in different directions randomly to get more interesting result. And we can use the pufferfish component, which is called rotate world. Rotate world. And we're going to start with a, for instance, we can start with an XZ plane, XZ. So if I put an XZ plane at every one of those points and then go zoom in, my plane display is really small. So if your plane display is like really small, like it is for me, you can go to display, you can go to preview plane size, and for some reason it's set super small here. So I don't know if I go to 1 and hit enter, probably want to do it bigger. Too big. So now you have an XZ plane at every one of those. And if we only use the XZ plane, all of your swirls would be like in the same direction. But I think we want to make something a bit more interesting. So, actually, if you look here at this top figure here, and I think I have a zoom in of it here. Yeah, like in this case here, you can see everything for the most part is in like the left-right direction. That's because I just used planes like in that direction. Whereas something like this, you can see the planes are in like multiple different directions. There's like a plane in this direction, there's a plane in that direction, and that direction. So changing those things can really change like the outcome of how the things flow along throughout this thing. So that's our plane. So rotate world, what rotate world does is it rotates in 3 directions, and by default it's kind of rotate. You can pick the axes, like you can do like rotate X and then Y and then X again. But in this case, it's going to do X and then default is Y, Z. So what that means is it's going to rotate the plane first, and then here's the degree for each one of those axes. So it's going to rotate this plane first in the X direction by the number we set, and then in the Y direction by the number set, and then in the Z direction by the number we set. And it's going to keep going through so that it's kind of organized downward. So if we wanted to see that simply, like before we get into like a more list of numbers, if I just took some sliders like this, just set them all to 0, so there's no rotation. So, and it's going off of the plane. It's going in the world direction. So there's also rotate Euler, which will go off of the planes, input planes directions, but we're going to just focus only on the world. The world is like world space, X, Y, and Z. So if I rotate these, you'll see now they're all rotating with the X-axis, like along the X-axis, right? So if you look down here, Rhino, that's X. And so you can actually see that it's rotating, like if that axis was like a pin or something, it's rotating on that axis. Or if you went Y or Z. Now, when you do them like this, it's like you can rotate this much X. Let me zoom in. So you can rotate, for instance, this much X, and then this much Y, and then this much Z. You see what I'm saying? So you get like these more complex rotations. That's basically what this component is doing. But we're gonna do kind of how to make the plane smaller. Yeah, just go to View, Display, Preview Plane Size, and you can change it there. Just type a number and hit Enter until it looks good. Can we use a random to randomize the plane? Yeah, that's what we're going to do now. So let's generate kind of like random values for rotation within some kind of bounds. The way that you do that is there's just this setup, which is pretty simple. So you get a random component, which is like this black cat in a box here. And then we do construct domain. Converts the curves into a mesh. This one, parameter pipe mesh. It's from Pufferfish, which is my plugin, if you don't know. Okay. So we're going to construct a domain. And so the first thing it asks us for R is the domain of the numeric range. So we're going to create a bunch of random values between two numbers. So between what two numbers is the numbers we're going to define here. We'll construct domain. So you can get sliders that go to 360. You just actually, if you want to change it after the creation, you can just right-click it, values, and just set the maximum also if you want to make sure you don't go past 360, commit. And we'll have two of these. So you're basically going to say, create a bunch of random numbers, but the numbers have to be between these two values. And they could be, they don't have to be low or higher. They can, if you go opposite direction, it's kind of nice. You'll kind of make a more opposite kind of list. So it could be the higher number first and the lower number second. And then the number of random values needs to equal the number of points, right? So these points are representing the center of our spin forces. So we would use the same thing, count, count. So we want 100 points, 100 numbers for 100 forces we're going to need in this case. And we want, and then the last thing we need is just a seed. And the seed is just going to change. It's not going to change the bounds. It's not going to change the number. It's just going to change actually what values get generated between those two numbers. And I always tend to use a slider. I have no idea why, but I always just use 1,000 for seeds. And so, as I change this seed here, if I just get a panel, you'll see the numbers change, right? But there are still always 100 of them, and they're still always between these two numbers. Okay. So I'm just gonna group that. And so this could be for our space here. So this can be for the first rotation. And then so since you have that, all you need to do is just copy that 2 more times. So just copy that whole thing, and we'll just change the values basically. And then you just plug this into 1 degrees, okay? And I'll just name these like rotation 1, 2. And yeah, and so this component also work like if I were to plug a geometry in here, it would do all the rotation stuff we're doing now to that geometry. But in this case, we only care about the plane, which is this final result plane. So this is the plane through each step. So this is going to be the plane corresponding with this rotation. This is going to be the plane corresponding with this rotation plus this rotation. And then this is going to be the final rotation, plane 3. So we can just get a plane. That's all we want is that last plane there. And that's going to be our, that's basically going to be our, our plane, which is the center and orientation of the discs. Right. So now if we go and look at our character here, right, you can see we've got all these kind of spin forces going on around, throughout this thing here. And you go through and you can change all these things. Like I can change, with the Y kind of seed is. I could change what the Z seed is. I could change all these values. I could say like, well, maybe I only want Y to go between 0 and 45, let's say, something like that, right? So you're just changing all of these directions. So like if you wanted everything to go in the same, like a similar direction, you can just give them, like you can make these all 0, for instance, and then make this, just like this. If you make these the same number, like 115, now everything's going to be 115, right? And that's kind of how I did that laying down body one, where everything's kind of like stacked looking, right? But if you want the more random you want, then you just change these numbers. And change numbers and change seeds. Okay. So now we have our orientations. We have a few other pieces of information that the spin force needs. Let me just save. I have a few other pieces of information that the spin force needs. We need a strength. So how strong are these spins? We need a radius. So how big is each spin disk? Like what's the kind of, how far does it reach? And then we need a decay. Like what's the kind of fall off? So as things gravitate into these things, like how strong is it in more of a center and then kind of falling off? So the kind of way to explain that is like, strength is obvious, right? It's just like if you have this force, like how strong is the circle? Like how strong is that? If you have this force for radius, it's like how big is that radius? Does it only reach that amount, or does it have an influence over more things? And then decay is interesting. So what decay does is it says like, okay, you have your strength S, and you have your radius, right? So this has a certain strength and radius. If you had no decay, it's just going to be stuck in that radius at a certain strength. But with decay, you're basically saying, okay, from like the center, start with the strongest possible, and as you move out, so you basically get more like a spiral. As you move out, be less and less strong, and then eventually it would like escape, let's say. Whereas if you had no decay, it's just gonna be like if the part goes here and it's very strong, it's just gonna like stay in. Out of balance there, but it's just gonna like stay in there. So that's basically what that means. Just assign the curve. That's it. Gets converted. Assign the curve as mesh. No, so curve goes here as curve, and parameter pipe mesh makes it a mesh. You don't assign it as a mesh. I don't, yeah, that won't work. Because if you have a mesh and then you go like this, and then yeah, you can't even set it in there. So yeah. So anyway, so now let's create the strength. And again, all of these are the same exact thing. It's just the values are different. So this can be strength. It's just the values are different now that we're not using rotation, because as everyone knows, rotation in degrees is to 360 degrees, right? So strength, you can let's say so strength can be also like positive and negative, which is interesting too, because if you change the strength, if you change the strength to be negative, that's how you can like flip these to go to the other directions. Like, so instead of going this direction, they can go the other direction. And you obviously don't need like 360 strength. I don't know. I'm just gonna make these like values. I'm gonna go like maximum 50 and minimum negative 50. And I'll do the same for this one. Values maximum 50 and minimum negative 50. Okay. So now you can go negative values as well, right? So now that you have that, you have your strength there. We'll copy this again and we'll go to radius. That will be, next one will be the radius. So radius. And radius can also be 50, but you wouldn't need, it doesn't make sense to have a negative radius. It's not really gonna do anything. So we can just change this back to 0 on those ones. So it's just 0 to 50 on the slider. And we need a decay. And decay can also be like a negative decay. So I'm just gonna grab this one that we use for strength and use the same thing. Okay, and I'm just gonna, I don't know, let's just get some values to start with. Or I'm just blindly typing things in just for the sake of starting somewhere. And 6. Anyway, so now we can plug those all in. So we're going to get our strength. And you can actually see, because we have a negative influence here, you can see some of them flip direction. If you watch in the Rhino, if you watch the arrows as I plug this in, I guess that wasn't a good, there was some. Okay, so you can see this one. This one happened to get assigned a negative strength. So you'll see the arrows flip direction, you see, in that one there. Radius. Now you have all these different sizes. And then this one is decay. So just decay has no visual input. It's just something that you have to understand. Decay means the strength is in the center of the radius and falls off towards the exterior of the radius. And bounds, we don't need an optional. We don't need another bounds for this field. That would just be like if you wanted to contain it in like a bounding box, but we're not working with bounding boxes. If we were working in just a box, it'd be a lot easier. Because we wouldn't need to then later on define how do we keep this thing into the body. So I'm just going to start by plane now, so that just so So turn those off just so it's easier to see just the forces. So now you have a bunch of these forces that are like randomly placed. There are randomly rotated and they have random strengths and radius, but random in a sense that they're still controlled. We control, we control the bounds of what's allowed to be random, in which case what it can be between, and we control the random seed. So you can see that changes even as I control the seed. If I wanted like to allow like much bigger radiuses, or if you wanted everything to be, for any of these, strength, radius, decay, or rotation, if you ever wanted everything to be the same, like say you wanted the same radius everywhere, just give them both the same number, and then everything will be the same. But in that case, we want something a bit more interesting, so we'll do something like that. For now, we'll just start there. So that's basically how you define your field, and we can evaluate that easily real quick before we get into Anemone. Is we can populate the skeleton. Populate geometry. So we're going to do another populate, but this population is going to be for the start of the particles, right? So this population here is for the start of the forces, the spin forces, and this one is going to be the start of the particle trails. So I'm just going to go ahead and I'm going to take all of this here. I'm going to group it. And this one here, add group. And so we're going to say that this is the kind of spin forces. Okay. And yeah, so let me actually just give things some room here. So spin forces and geometry here. So populate geometry. In that case, we're doing same as we did before. We're populating on this, but we're going to use a lot more points here because we want a lot more trails, right? So this is going to be kind of like the density of your trails. So I'm just going to make a slider, and I have a pretty decent computer, so if you don't, you might want to start small. 1,000 should be okay for any computer. So you see it's a lot more like dense that we're making along there. And we're going to get a seed again. Seed. And you can change that seed as you see fit. So if I wanted to display like the fields, it might not look so interesting yet, but let's just see. There's this merge fields component. We don't really need it, but I'll use it anyway. All it's doing is like a join for fields. So if you were to play with more of these, you can feel free to explore any of these if you want. I just like the spin force for this specific character. But there's other types of charges you can define, like point charges, whatever. Spin force, point charges. I mean, just look at the inputs. It's again like decay, charge point. So this would like attract things like more towards a point, let's say. And then you would just plug all your fields afterwards into this merge field. So that's all that's doing. But I'll just use it anyway. And then what we want to do is we want to evaluate the field. Evaluate field. And it's asking for the field, and it's saying like at what point do we want to evaluate it. Well, this is the only points we have right now, so we'll just use those points for just to see what's going on. And basically what that's doing is that's just giving you vectors, right? So when you evaluate a field, it's just giving you the vector of that point in the field that we've created. So I'm just going to get a vector. And again, in fact, these parameters are just for like organization. They're not actually changing anything. So if we wanted to see those vectors, we can get like vector display. I just want to check something. Yeah, okay. Sorry. My Zoom tab went missing for some reason. Okay, so vector display. And we'll get the vectors, and then the anchors will be the points. And if I hide this, so you'll see at this moment in the vector field, you can see like where each vector is going to basically go. Let me actually I'm going to unitize the vector so that they're all the same length. I can just want to get it more obvious. Okay. So basically, this is just showing you at this step, like in the very first step that we'll do, the direction the particle is going to move. Right? So if we just make that extreme, that's what it ended up with, you know, for our spin force. And again, that's just the first step. And then the next step would be another direction, another direction, another direction, but just so that you see how these things will move in their first step. But what we're going to do is we're going to move these particles with Anemone through this field, and that's what we'll get up to next. I think we should take a break. I'll leave this part of the definition on the screen, and I'll also save it if anyone wants just to save it. So let me see. Just zoom in as much as I can here. Just put that on the screen for you. Okay, so and let me preview this. Okay, so let's take a break, and then we'll get back to the definition. See you all in let's say about five or so minutes. Okay, I'm back. Yeah. Before we start, I just want to remind everyone, feel free to take screenshots and of the webinar and tag us and stories, and we'll reshare them. It's always exciting to get it, to do that, just to see what everyone's doing and going on, and everything is recorded. So yeah, take some screenshots as we go along. If you see something on the screen you think looks cool, post it, share it, tag us, we'll reshare it. It's a lot of fun. So anyway, back to what we're doing. So now that we have these forces, what we need to do is we need to move points through those forces. And we want to do it step by step. You could create field lines with Grasshopper, but they're terribly slow, hard to use, and we can't kind of like interject to make that kind of sharp-edged discrete flow that you see in the geometries here, where things are at like more kind of hard angles, like you see in this leg here. So that's why, we're going to kind of use Anemone, which lets you do loops in Grasshopper, to kind of step through this field and create those particles. So what we should do now is vectors, and let me turn this. Okay. So now that we have this, we need Anemone, and Anemone is basically two main components, and they're basically loop end and loop start. There's fast too, if you really want to go fast, but these will only output after the end, so you won't be able to see the animation. And I think it's kind of cool to be able to see the particles flowing through these fields. So we're going to get a loop end, a loop start, and a loop end. And these components work together, and they always need to be connected, and the connection is through these two arrows. So the first thing you want to do when you get Anemone is just connect those together. Okay. Now, the second thing that we want to do is we want to set the output of Anemone so that we can see the animation. Is we want to set it to constant, and then we want to say record data. So it will keep all the steps together. Because if we just do constant, output without recording data, it's just going to keep outputting the current step, and it won't give us all the steps that we need to use to connect the polylines. Put as one entity. I got each curve populated. Select all the bones and then set multiple curves. And then put them in parameter pipe mesh and then join them. And so this and join. And then you do the VDD stuff here. So the way this works is we need to, so again, constant and record. So the way Anemone works is we need to give it a amount of times to run. So we'll just get a slider like 100. So that's going to be how many times it loops. And this is just going to be the counter. I just put this here so we can know what step we're on as it runs. And then we need a toggle, which will just trigger a restart, basically. So if you want to trigger a restart, you can double click the component or you can use a button. So I'll just use a button. basically like if you click this button, it's gonna like restart the whole kind of loop thing. So before we plug anything in, basically what's gonna happen is we're gonna plug in input geometry, which will be our points, let's say. So I'm just gonna draw for a second. We're gonna plug those in, and they're gonna output here, right? And then what's gonna happen is we can do stuff here, so like move or whatever. So we can do stuff here, right? And then that stuff is gonna go back in, and whatever we did here is gonna go back in. It's gonna shoot back over here, and now that's going to output from here. So now that's going to output, right? And it's going to do that over and over again until the iterations run out, and it's all going to aggregate as an output here, all the steps. Okay, and that's a loop. So that's basically what it's going to do is we're just going to keep coming through. We're going to change the information. Information is going to go here, it's going to go back to the start, and then that information that was changed is going to become the new start, and we'll change it again and again and again. That's how a loop works. So we'll plug those geometries in here. I'm just going to hide these forces for now. So plug this in here, and I'm just going to get a point component container here, just for just organization. And we're going to do basically a bunch of stuff, and then we'll output at the end. So I'm just going to move the end like way over here. And so now those points are actually what we're going to use for like this stuff here. So we're going to evaluate it at each step. We don't want to evaluate only just always the first step. So we're going to evaluate each step, and then if we want, we can just see the vector display of each step as well. All right, so all right, so now what we want to do is we want to move those vectors in each step. And the way that we're going to do that is with this vector and an amplitude, right? So if we get amplitude, right? Amplitude, if you don't remember from math, is basically a vector direction and an amount to move. It's basically multiplication. And in fact, I think you could use a multiplication component to do this as well. I like the amplitude just because I like the explicitity of it, like how I just can recognize what it's doing. And so the vectors, I just missed a step of point input. Points to fields, I guess, maybe if that's what you mean. So the vector is this vector. That's our vectors. Vectors from our field. And actually, I'll just do like closer. So vectors from the field, and then amplitude is going to be like what's the distance when I plug the points into the evaluate field, it triggers an error. Points should not be in evaluate. Points and field. Do you have points in P? I don't know. Yeah. Just put points in P and then in F. If you know what the error says, you can write it, but you know it should just work like that. And then you can also download the definition from the Dropbox, like the as I'm going, if you need to. So then the amplitude is basically gonna be like, how far does it go in each step? Like, so if we theoretically had a field that was like this, and we want to move points in it, right? We're just saying, okay, at this point we evaluate, and it's at that direction, and we want to move one step, right? And then it's gonna go here, and then it's gonna evaluate again, and then once one unit, and then evaluate again, right? So that's the kind of unit that we're making here. Is here. So we'll just set that. I don't know, we can do 5, but we can start with 1. Like so, and the smaller the unit, like the more tight the the more accurate and tight it will be. Okay, so we'll say we're going to go 1 unit, and now we're just going to move. So we're going to move the points. So again, we're going to move these points here, these same points. We're going to move them by this amplitude. Okay, so we're going to move that. And you can see, because we're only in the first step, you can see that they moved 1 unit in their evaluated vector from where they were, which was here. Fields could not be evaluated at given location. I'm not sure. Maybe just download the file. Could really be anything. And then there, and then so now that we're moved those points, we could just plug those in here, D0, and you can see how it starts to grow. Right. So that's just like without doing anything containment or anything like that. And so before we get to the containment, let's look at how to look at these as as curves. So you can see the pathways that it's taking, right? But right now, by default, the panels can get a bit heavy when they have a lot of numbers in them. Just delete that. So let me use a tree branch. Okay, so basically what's happening here is that there's a bunch of branches, 100 branches, and that's representative of the amount of loops. So it's saying like for each loop, it's putting like 1,000 points. So what that means is if I have let's say 2 points, and they're both going in, we're generating in vectors like this. And let's say those are all my steps along. Right now, it's keeping track of them per generation and not per, loop along the path, let's say. So right now they're grouped like this, right? So that's like with all of the points, that's generation 1. With all the points, that's generation 2. With all the points, that's generation 3. And we want it to read like each generation per its own point. So we want it to read like that. So, if I tried to make a polyline here, polyline here, it's gonna look crazy. It's not gonna really make sense because it's connecting them in the way that I mentioned that it's connecting them, which is by generation, and we want to flip it. Let me just. Let's just see. Two, so again, it's doing this right now. It's like connecting things across like this because it's keeping track of the generations. So it's this is one generation, and there's like 1,000 points because we have like 1,000 points, right? So generation. And we want it to read this way in the data structure. So a really easy way to do that is what's called flip matrix. Somewhere. So we just do flip matrix. And with that, actually, let me get the tree branch maybe so we can see it better. Okay. So we're going to flip the matrix. And so now, basically, it's done exactly what we want it to do, which is now this is the amount of items per branch. And now there's 1,000 branches. Okay, that's basically all that we did there. Is flip that so that we went from grouping them by generation to grouping them by, let's say, by path or something. And I'll draw this better. So, so now if we use the flip matrix instead, now we get these. Okay. So now we get those along there. So if I just turn off the points, so we can see those better. Now you can see that we have those curves in those flows there. And you can see like if I went to like 0.5, which would be like a tighter, like the steps are going to be smaller. And I go back here and I just click this button and we can restart it. And you can see things are now like spinning in a tighter fashion. Okay. So pretty cool, pretty fun stuff there. But the problem is obviously it's not inside of our body. So that's what we got to do. We got to get it inside. We got to get it to stay inside of our body. So, and just as when you make polylines like this, I like to then just do a simplify curve. This will just get rid of any points in the polyline. It'll make the meshing easier that are kind of overlap or very close to each other or redundant. It will just like automatically get rid of them. If you had a polyline that was like you had that and you really want like this, but because of the way the paths are, you might end up with like, I don't know, a few points here or something. It just basically gets rid of like those redundant stuff. So and I'm just gonna give this a color so it's easier to see. Swatch. Blue or something. So it's easier to see. So let's run that one more time. And you can see here's like the steps, right? Here's the counter, like which loop you're on. Now, if you were to like, this is what we're talking about, like, you know, if you were to, I don't know, make these, let's say the rotations, like if you were to make them 0, 0, and if you were to make these both like the same, you'll see that they're all going to be doing the same, like this kind of like layered thing here. And you can see they spiral because of that decay, right? Like, so you can see that they expand, right? They're like kind of escaping that kind of whirlpool that's because of your decay settings. Okay. So I'm just gonna put those back to what values we were using for now. So let me run that one more time. Is everyone able to get some kind of swirl going on there? All good? Anyone want to respond? All right, so we're good then. And also keep in mind, like this is the other things, there's just so many things you can do, like the density there. Like if, for instance, if I if I don't know, if I used like bigger radius, let's say. Like if I really made this radius huge, let's look at this spin force here. Yeah, if I really made the radius big, 20, how big is 20? 20 is pretty big. And even go to like 50. Like if I went like 30 and had like less of these, like say I didn't have 100, what if I had just like 10, like that, right? So you're going to get more, completely different outcome, right? It's more like bigger scale. You see how like it's just dramatically different. It's not so tight like anymore. So you can get just like infinite results with these things. It's a lot of fun to play with. I mean, you can just be sitting here for hours until you find like the right thing that you like. The last commands were complicated. Yeah, this part is not easy to understand. This isn't easy to understand. You really have to understand like how lists work, and it just takes time and practice really to understand how that works or why that works. But the important thing is to know that you basically just need to flip it here so that we go along the trails. So even that looks pretty cool, like as an abstract thing. But for now, I'm just going to go back to what we had, which was, I think, like 100, and these were much smaller, just like 5 or something, just for now, until we get a bit more to where we're going. Okay, so now that we have that, let's talk about containing, and then we'll talk about discretization. So how do we contain this in our body that we've put here, which is basically this body, the red parts and the joints. Let me just turn this off for now. Just all this stuff. Let me save. And I want to give this a bit more space. So we should remember that these always need to be together, right? That's like the outside of our loop, and then all this stuff that's happening inside, that's like the inside of our loop. And let's say that this is the trail start points. So trail start points. All right, so now that we moved all those things, let's move them, but give a rule that says if you're a particle, you're moving about, and you happen to exit the body, what we want you to do is say, okay, I exited the body, so what I need to do is find the body, go back in it, right? So that the particle becomes, something like the trail becomes something like that, right? So that we don't ever exit the body in the trail. So the way we give it that rule is we're first going to bring over our body, which was this here. And I'm just going to grab yet another mesh container, just so it's easy for me to drag it over here and use it. And I'm actually going to unplug this now because we're going to use the contain rule and then plug that in. Okay, so we have our mesh and we have our points. And let me actually restart the thing so that they're in there. So you have your mesh, you have your points, and we can do mesh inclusion. Mesh inclusion. And we're going to say, okay, take this mesh and then take these points and tell me if anything's outside. In this case, nothing should be outside. Maybe a few down over here in the hand area. But other than that, everything should be inside. So that's basically giving a true or false value. Is it inside the mesh or is it outside of the mesh? And we're going to do a sift pattern. And we're going to take these points and we're going to sift them by that pattern. And what sifting means is basically what we've done now. If I just get a data container, data is just a generic container that can hold anything. And it's just so we can see the two inputs easily, two outputs easily. So I can see here, one is inside, and like if I go to the hand, it's more obvious because there are some points outside the hand, and then the 0 means they're outside. So we've basically isolated the outside points from the inside points. But there's another component which is called cull pattern. There's like cull pattern that some of you might be familiar with, which is going to give you the same results. But the issue with cull pattern that we don't want is that the list changes. And what that means is here you're actually, with cull pattern, you're actually deleting, with cull patterns or dispatch, even like we do this, we can look at dispatch. Dispatch is probably even closer. Yeah, let's look at this dispatch as a better comparison. So I think a lot of people overlook the sift pattern. So dispatch is actually deleting from each list. So if I look at this with the tree here, you can see that there's 954 items and 46 items, right? So there's 46 points outside of the mesh and 954 inside. They're the same result, it's just the data is different. So what sift does, if I bring this over, what sift does is you can see there's still 1,000, 1,000. And the way that it does that is instead of deleting things, it places a null in its place, right? So you can see that there's null, right? And the reason it does that is so that it keeps track of how the list was structured, right? So these should be inverse, which they are, right? Where there's a null here, there's a value here, there's a value here, there's a null here. So those things need to be, we need to keep them together so that we can do stuff to the points outside. We can do stuff to keep them back inside, and then afterwards we can use a special component called combine data. And what combine data does is it looks for those nulls in both lists and basically replace them. Like whatever's a null in one list gets replaced with the other list and so on. And now our list is back intact and in the right order, right? But we're first going to do stuff to this, then combine it, and the nulls will be replaced and everything will be back in order, which you can't do with things like dispatch, because dispatch actually changes the amount of items read in the list there. Okay, so this one, we don't have to do anything because the points are inside, they're fine. We don't have to do anything with them. This one is the one that we want to say, like, get back inside of the body. So the way we're going to do that is we're going to do mesh closest point. We're going to take these points and we're going to pull them to this mesh here, to our body. Right. So now if I click, you'll see that they went from here back onto the body. But that's not quite enough, because when you're dealing with things like tolerances, it could still be considered outside and could still escape the mesh like a lot more. So what we want to do is we want to say, okay, pull to the mesh, but also then use like nudge inward a bit. So we want it to like actually nudge it inward instead of riding right on the mesh. So what we're going to do is we're going to get a vector 2 point. So vector 2 point, and we're going to make a vector from the original point that's outside the mesh to the point that's on the mesh. So now you have a vector. We can actually do like a vector display. And we can use this as the outside point as the anchor and vector. So you can see if I zoom in there, you can see that you made these kind of vectors that are pointing. It's basically giving you the vector that we pulled, basically. And you're just going to increase, you're just going to multiply that vector so that it goes more inwards, but in that direction. So we get a multiplication. Get the vector, and we'll multiply it by some number. It doesn't need to be a lot. It can be 0.25 even. And we're just going to then get the, we even need to, yeah, we do, because the vector, yeah. Okay. Yeah, so then we should be able to then just move. So get move, and we're going to move these points that we've pulled onto the surface here, that you see there. We're going to move them by that vector. And it goes red. Why? Because I mean it worked, but it doesn't feel like it worked. So if you want to just get rid of the error, like if you don't like the red, you can just do amplitude as well. Amplitude, and just use this as the amplitude, and as the vector, use our vector. I'm just going to make some more room here so I can make these wires more clear. Okay. So then just use that. So now you'll see if I increase this multiplication, you see it's like going more in to the value we set here. So 0.25 is enough for this case. So that means basically we just nudged it in. We pulled it, got the vector from the original to the pulled, and then moved along that vector to be a bit further in. And once we've done that, now we need to get it back into our list in the right order with the ones that we didn't change. And that's why we like the sift component, because we can then just easily just do combine. And just combine these two together, and they're back in their right order. So you can see if I go here, you still have those nulls carrying through, and they're basically just getting filled with the ones from that weren't outside of the mesh. And we're just basically replacing the points that were outside the mesh with the new ones that we've pulled inside of the mesh. That's all that's happening there. So now that's what we're going to plug in into here, into zero, do zero here. So let me just unpreview this stuff. Put that here. Okay, so now you see that now we're stuck inside. So we'll just let's just let that run its course. So we reached 100. So now we're in the body, right? So if I go to the body here, body, right? So now we're in the body. And again, I'm not using that many points. Also, it depends like how many spins you're using. Like all these kind of factors will change how these things get arranged throughout your body. And you can see like what I was talking about, like you see there's kind of like a blank spot here that maybe you don't like. You can always go back and just say, I got my bones layer. Maybe you can draw a new one there. You can go from like here to here or something, let's say. And then you would just get all your bones and select objects, and then just go back here to the beginning and set multiple curves and let it start over, and see now it's filling out in that area. So you got to play also with like the bone structure as well, like basically where the particles emit from makes a difference as well. So those are things you can micro adjust and play with as you're doing this, and I suggest that we do that. So that's really cool, I think. For now, we'll get into a few more things here. But yeah, the joints too, like because we made that solid body. Remember, that's why it's like. So there's just so many things to control, and a lot of flexibility. That where the bones are, how many points you have, how many spin forces you have, how many iterations you have. All these things matter. It can change quite a bit, like how this thing ends up looking. But all in all, it's a pretty fun exercise. You can see there. And if you were to let this run, I'm not going to do it now because I don't feel like waiting, but if you were to let this run for even more iterations and have even more points, it would become like fuller and fuller. But I don't feel like waiting around here. So So let's just say that this whole thing here is keep points in body. Okay, so that's the rule there, to keep the points in the body. And just as a recap, what we're doing is we're saying, okay, points move, test if they're inside the mesh with here, sift it, take the points, separate them that are outside of the mesh, pull them back to the mesh, create a vector from the original point to the pulled point so that we can move the point even further into the mesh with that direction, and then combine it back and complete the loop. Does anyone have any question about that? No questions? Okay, we'll keep going. Lines are still going outside of the mesh. I'm not sure. Just try downloading my file. It seems like, yeah, I'm not sure. It seems like you're having some issues with your fields or something, even from before. So. How does the point command from loop start? You mean this point here? Yeah, so this point is just a container. It's not doing anything. It's just holding points. All it's doing is you have initial points. All right, so initial points go in. Those are the first points we use. Those points do all, what they do here. They're evaluated in the field. They move. They see if they're outside the mesh. They get sucked back in. And then the result points get put in. And then those result points get sent back here. And now those results are these points. So they keep looping and looping and looping step by step. So if I went to like here, and I just did that, right? That's the first step. And then, so the points here, and we can actually look at it, right? So actually, if I go to 0, yeah, so 0. So these are the first points, right? Everything here happens to those points and gets put back here. And now, if I go to the next step, now those are these points. They moved, right? And then everything happens to those points. And now they're these points, right? So they just keep moving. You just keep reusing points. Okay, so it's just you're just using it over and over and over as a loop, basically. But you just need initial points here, where we start from. Those are the first points. But as you can see, after we've done 5 loops, the initial points have moved to here through those 5 steps. Hope that makes it a little bit clearer. Yeah, amplitude test. Yeah, so that can happen actually if your amplitude is high enough that it ends up shooting back outside the mesh somewhere else. Then that would happen. That your your things would go out. Like if you had a mesh and a point, and your amplitude was so high that it went back outside the mesh somewhere else, that could definitely happen. That's why I just use like a low number, just to just nudge it in just a little bit. The amplitude here isn't for anything design wise. It should just be it's more like a tolerance. It should be a very low number, just so it's not exactly on the mesh. It's a little bit in for the math, basically. Okay, so we have that. We have our swirly thing here, swirly creature, which looks pretty cool. So then what we do is the next step is we're going to look at making a kind of discrete vector from that. So let's look at the discrete vectors here. Do you guys want another break, or you want to get right into the discrete stuff? Or do you want to play with these swirlies for a few minutes? I don't know what you think. Any thoughts about it? Discrete stuff, break, discrete stuff. All right, let's just give 5 minutes, another short break if you want to just play with this stuff. Let me save it so you can, let me save everything so you can download it if you need it. 6. And I don't know if I could fit all of this. It's about as much as I could fit on my screen, if that helps. So it's in their files if you need to download it, if you can't understand it from the screen. Yeah. So play with it a bit, and let's reconvene in 5 minutes. Okay, I'm back. Can we use the initial amplitude of a vector to pull the point again inside the mesh? I wouldn't. I wouldn't because the initial amplitude is just this vector is just going to get you on the mesh. So we're multiplying that to get it more in the mesh. That makes sense. Previous amplitude. This one? No, this is the only other amplitude. No, I wouldn't use that because they're not the same. They're not meaning the same thing. This is just the amount that it's moving. That's the amount the steps are moving in. This we just want a small number that we get inside of the mesh. And actually, it might even be better to just do addition instead of multiplication. It might even actually make it easier. That's not. Yeah. I mean, you can get like the amplitude if you do like deconstruct. Where's deconstruct the vector? Yeah, we can do that, but it's easier to just multiply it, honestly. It just makes it easier. But they're not the same, so I mean, this one's just controlling the step. So like if I gave this a huge step here, you see how big everything gets, right? That's just like the distance each step is taking. So it's like less resolution, let's say, which also kind of looks cool. Like if that's what you're going for as well. So that's just basically like resolution. If I went like to 0.5, it's going to be very tight here. But we just want to like just nudge it in a bit, right? So this is like even a tighter resolution, more swirly. So no, they're not really attached to the same function. They don't really correlate in any way. So that's even like a tighter. We can go with 1 for now. All right, so let's look at like making these things like with some kind of discrete flow in them. So it's pretty simple, actually. All we need to do is we just need to come in at this point here at the amplitude and build something in between there. So I'm going to give myself some more room here. And we're just going to say that this is the move. So this is going to be, I'm just going to group these. Let's say this is like move. Points. Right. So we're going to build something in this area here between the vector and the amplitude. So first thing we need to do is we need to get our component from Pufferfish, which is called closest vector. And we need to get some vectors to kind of override it. So yeah, there's recording. So the target vector set. So we want reference vectors, right? So our reference vectors to search from are going to be our vectors we have. So we're going to search from those vectors. Now we need to give it target vectors, and I'll explain this in a minute. But we have some components. We have the vector star. These are pufferfish components, and we have the vector world. Vector world. And we can even just put our own vectors if we want it. So what these are is, if I go here, I just right-clicked it and then like zoomed to it, right? So if I go there, you'll see that there's like this star, right? And I can increase the number. So the number of subdivision steps will give me more vectors in that star, right? So, okay, so those are going to be directions, right? And we have also a, if we wanted, you can make it 2D, but we're going to use 3D. We're going to move in 3D space, right? But you could like, we're showing this too. So we could stay just in like the 2D plane if we wanted. But we're not doing that. We're going to be in 3D. So essentially what's happening here is we're saying for each step of the vector field, find the closest vector here, and you're only allowed to move in that direction. So what that means is, if this was my vectors that I'm saying we're only allowed to move in these directions ever. And if I had some vectors that were moving, let's say, like in a spiral, let's say. And as a polyline, it'd be a polyline, but in the resolution we're having, they look round. Okay, so all this is doing is saying, okay, for each step, go to the beginning of the step. So here's our rules. And when you find a vector, find the closest vector, and that's the way you're allowed to move. So in this case, this vector here is the closest vector, right? So instead of moving this way, it's going to move this way, right? And then it's saying, okay, now go to that one. And the next vector is this here, right? So if we went here, you can see that this upwards direction is the closest vector, right? So now this is going to move upward like this, right? So that's basically all it's doing, is it's just going vector by vector to each star point and checking it. So then again, this one's going to be up because it's the closest one. So Yasmin, yeah, I already answered you. Yes, there's a recording. You can just check the website. It's all information is there. Now you basically go from, if you look at these three vectors, you basically, because you're saying you can only move in these four directions in this case, instead of these three first ones, you end up with this, right? So that's how that's working. So if I went to the next one here, we would see that, I mean, I don't know technically, but it looks like right in the middle, but let's just say it ends up being that this one here is closest. So now this is going to move this way. All right. So these four vectors ended up doing this because we're saying you can only move in these directions. So that's basically what's happening. Okay. So now that you have that, these are the vectors in 3D space we're going to start with. We'll say you can only move in those directions. So every time there's a vector, find the closest one and use the one from this instead. So that's going to be our target vectors. And that's pretty much, that's pretty much it. It's just that you're assigning vector roles in that way. So if I just use those vectors now into this vector amplitude here, like this, what's going to happen is if I rerun this thing, you see how it's only going to move in those vectors. Somewhat still following the same, kind of flow as the other one, but it's restricted. So if I were to, if I were to add more to this, then the more kind of rounded this would look. So if I had like a bunch of vectors in this, it would end up just looking like the regular one. I could put one, let's say this, so add another step to the resolution, and now you can see they're more swirly than before, but still like hard line. And these are just, these down here, they're just other ways to generate those vectors. So vector world, for instance, doesn't have a resolution. It's more like you can do, there's 3 different types. There's cardinal, intercardinal, and cardinal plus intercardinal. So if I go like this, and then this, so you see like you're seeing the plane. So let me just get the hide this so you don't see the plane. So you see that's just like what's called cardinal. Like if you know like anything about like maps or anything like that, that's intercardinal like that, which is like the intermediate. So this cardinal is like north, south, east, west, and then that's like northeast, southeast, northwest, whatever. And then this is combination of both of them. Whereas vector star lets you play with resolution, and then lastly you could. So if I use this one here and I only want it to go in the intercardinal, just like that, and here, and we'll rerun this again. So it's only going in those intercardinal directions. Okay, so, and then the other one is just vector. Like you can make your own vectors if you want. One way to do that is you can just draw lines and set them, or you could go anywhere and you can just say like set multiple vectors, and it'll let you like draw the vectors. I don't know, let's say you want it to only go like to the right and back. So there's just only 2 vectors in there. So let's see what this thing looks like with just 2 vectors. So you see what's happening there, right? Because it doesn't have any vector even that can move it upward, right? So it can only move to the right and back. But again, just all like kind of stuff you can play with. Maybe if we gave it like, but it can never move to, for instance, like the left, and that's why everything is going right to the right. Let's try set multiple. We can go right, back, and up. So now we're allowed to move up too. So that's also kind of cool. Really just depends like the look you're going for. But just the point is that you understand that it's basically saying for each step, find the closest vector to the vectors you're allowed to move and move in that direction. And I hope that that makes sense. For now, I'll just use that. And the other thing we can do is we can set a filter here so that we can switch back and forth between using these kind of like hard edge ones, the discrete ones, versus using the the non-discrete one. Just move some stuff around here. So in order to do that, all we have to do is set a filter. So we can do stream filter. And we can plug the original vectors here into 0. And we can plug the closest vectors into 1. And plug that into amplitude. And what that will let us do is so what that's going to let us do is it's going to let us switch between the smooth curves or the discrete curves. So I can just get a Boolean, just get a toggle. And this way you don't have to like unplug, plug. So if it's false, it's going to be 0, means it's going to use regular vectors. If it's true, it's going to use the discrete vectors. So as it's false, now you're back to your smooth vectors. And then if I switch it to true, you'll get to the discrete vectors. So that's that. And then, so if I go back to true here, true, and right, and now you're back to your, whatever you've set as your discrete vectors. What controls the density of the curves? Any way to add ignitions for this? The density curves is right now is just this. The density is by your start density and also what's everything you've assigned here, like how things are decaying and spinning and their radiuses. So it's really about playing with your field and your start points. If all the points only started like down here in the leg, then like basically all 1,000 points would start down there, like super dense in the leg, and probably won't even make it up past the hip or something. So you can define those points in another way, but I'm just using populate geo right now. It's more evenly distributed. And then again, your field is going to really change like how things are flowing, especially things like decaying and radius and strength. Another cool thing that's interesting is because Anemone is kind of like live, I'm just going to take this toggle and just drag it over here for a minute. You can actually like switch back and forth between like while it's running. So you can like start smooth and then go discrete, midway through and maybe then go back to smooth. So that's kind of interesting too, that you can kind of interject while it's like kind of mid loop and have like a mix of like smooth and then discrete and then smooth, or whatever you really want to do. So that's kind of like an interesting feature of being able to kind of getting into the loop there, that you can do like weird stuff like that. So that's, I mean, that's about it for the curve, the particle flow stuff. Everything else, like in terms of this flow, is all really based on how your start points are defined, like how many bones you have, where your bones are defined, and like what your field is doing, and the amplitude, like how much you're moving. Those are kind of like the things that, even small changes can dramatically change like what's going on in the result, which is a lot of fun. But it also is like you can just be sitting there for hours, like just playing with it and finding all these kind of cool and fun results. So I'm just going to organize a bit. I'm just going to say, okay, so this is the discrete vectors, and this here is the field. Field, and this is like smooth, discrete. This is just like the movement. Okay. So save that. Just want to make sure that there's some labels here. Okay. All right, so now we're over here, and the last step for this part is to make these in curves into meshes. So we're going to get a curve on it, and we're going to flatten the input. So we have all these curves flattened. And this part here, so everything I'm going to do now, you definitely want to have off. So you just can go here and then just like disable. Anytime you run the simulation, you don't want to be running all the mesh stuff. You want to run that after you find like a flow that you like. Otherwise, it's just going to be painfully slow, even on the best computers, to like run all this while making the mesh in each step. It's just going to be very, very painful. So just make sure you stop at like this point for the curve, for the creating the. So we can just say this is the particle trails. Trails. All right, so what we're going to do is, instead of using pipe, I just thought I'll show something else. So we're going to make our own pipe here, so you can understand like kind of how like pipe is created. I think it's interesting. So we're going to get the length of each curve, and we're going to divide that length by a number. this is actually what I'm about to show you now is a really interesting trick. So we divide this by something. Divided by. Let's see. So divide by 10, and then we're going to do per frames. And we're going to, that's going to give us our number here. So the length divided by 10, number, right? Yeah. So let me shrink this. So what's interesting about this is basically what we did here is we divided by per frames. We divided the length to get the number of frames, which is, you can also do it with evaluate curve, let's say, or actually no, divide curve. Divide curve. So you might be asking, if you're familiar with Grasshopper, why do this rather than like divide length, which is basically what I'm doing, right? I'm dividing the length, right? Essentially, I could just plug this into here. The thing is divide length is the actual process behind the scenes is very slow because it's actually stepping along the curve at each length of a distance and like then putting a point. In fact, if I plug this in right now, which I'm not going to do, my computer will probably freeze and I'll get the same result as this. The reason why this is faster is because you're dividing the length as a number, getting the total amount per curve, and then just dividing the parameter space of the curve by that. So divide curve is very fast, and you can just get the division of the length manually rather than using divide length. Divide length is more precise, but terribly slow. And for this kind of thing, we don't need it. So it's a kind of a trick. And the same goes for like, if I were to do like per frame instead of per frames, and I wanted to put a frame at each parameter, it would be very, very slow compared to just doing a per frames based on the kind of what they call the kind of parameter space of the curve. So that's a nice little trick. If you don't know about it, you can just, instead of using divide length, if you don't need to be like super accurate, you can just actually divide the length, and then like the rounded number of that it will get rounded automatically here and will be divide curve. It's a lot faster. But we're using per frames anyway. We're just gonna go right to frames. That was, but okay, so what we're gonna do now is we're gonna make a rectangle on each frame. And it's you know, obviously too big, but what we're gonna do is we're gonna change the X and Y size. And X and Y are domains, so it's like negative to positive based on the center. It's really easy. You know, if you wanted to just use a slider, for instance, like this, what's going to happen is, if we look at this, if I do this, you could see that it's going, instead of on the center of the plane, it's kind of, let me try to find the plane. Oh yeah, so instead of going on the center of the plane, like it is here, what's happening is, if you only plug a single number, it's giving it the domain of 0 to that number. So you never go negative. So it's only coming off the corner there, right? So in Pufferfish, we have just a nice little shortcut component, which is called two-way domain. Two-way domain. And this will just give you the negative and positive for any number that you put as a domain. So if I put like something like this, the result is going to be negative that number to positive that number, and you can just use that, and now it's centered. So it's a nice little handy little shortcut there. So that's going to be the size of our pipe, basically. And we can go something a little smaller, 0.2 or something. We don't need to be like such a big thing there. So if I hide the frames, now you have all those like that. Right? And so now this is going to control the resolution of that pipe. So if I bring this down, if I divide by less, you're going to get more dense amounts of profiles along the curves. Right? And it's per curve, because we're dividing the length of each curve. So it's not the same number for each curve. You see here the numbers are all different. So if you went to 1, it would basically be you'd just be going 1 every 1. So the length divided by 1. And then you have just like, then you just get the number of segments basically is equal to the length. So you can do something like that. Okay, so you have your rectangles. So now we have this other components in Pufferfish, but the other thing I want to do is sometimes there's very short curves that don't get enough profiles, and we can omit those. You know, if there was a curve that was very small, it wouldn't have enough space to, let's say, get 2 profiles at least, which would be required, right? You need a start and an end. We can get rid of those conditions easily by just using a clean tree. And it's going to get rid of like null items. It's going to get rid of invalidity. And we can also say we wanted to remove empty branches even. So toggle for empty, we can set it to true because the others are true already by default. Just this one isn't, so we'll just set it to true. And then we're going to do, from Pufferfish, we're going to do a parameter mesh loft. Parameter loft mesh, sorry. And it's asking for the sections, and our sections are these, right? So before you plug that in, though, what we want to do first, so that we don't get too heavy, is we want to change this V direction to use 1, right? So what that's going to do is going to say between each span, make it just like 1. It uses parameters, and you can see more about this again in the example files of Pufferfish, but it's basically V is, if I had a profile and I had another profile, it's saying the number of mesh faces between those profiles should be 1. So it should just be like 1, right? So I mean it's 4 if our thing's rectangle, but it's 1 like across, right? So it's not doing divisions like that. So that's why we just set this V to 1. And then the other important setting we want to do before we plug it in is, for this case, there's an option here which is called length. And we want to control the division. Actually, sorry. So this one I just explained is actually this direction. So we don't want anything more in this direction. We want just one face like that. And then length is the length between the control points, right? So if you go length true, right? So what that's going to do, what that's saying is like I'm sorry, I got messed up here. So I was correct the first time. Okay, so V is the span, and if you set L is length. So section curve face divisions are defined by the lengths between their control points, right? So instead of, it's basically saying instead of defining this division with this U parameter, make it automatically understand the control points and make one division, so there's no intermediate divisions along those control points. So that's basically what happened. The end result is basically that between each profile, you end up with that. Just a single mesh face between each part of each profile. You will not want to use a normal loft for this. Unless you want to wait for hours and crash your computer, and we need meshes anyway. So yeah, so then you mesh loft this, and then so just let that like finish its loft, and there you go. There's your mesh loft. So there's all your like wires there. And what we want to do now is let me that. And the last step of this is we want to get rid of all those open ends. So if you look, if I can find, yeah, you see here, like they're open. We just want to close those. So again, with Pufferfish, simple close mesh, we'll get rid of all those openings. So we'll just go like this and then just close. And there you go. Now all the ends are closed. Beautiful. And then we're going to just join everything together. So join. We'll flatten so that everything becomes red as one mesh. We only need to be red as one mesh. And yeah, that's your result. So that's your result of this step. And we can even look at that if we just preview this, something like white. And if you go here and we go to like Arctic or something, get rid of this for now. Arctic. Yeah, so there's your swirlies with a thicken there. And I think this is the one where I swirled and then discretized and swirled. So that's why it looks like that. Again, so can we use Weaverbird picture frame here? I don't know what you would use picture frame for. I don't know. Yeah, I don't know what you would use it for here. Okay, so the reason you don't use pipe is a surface. It's not a mesh. We need a mesh. And I invite you to try to plug this into here when you have time, and make sure you save, because likely you're going to crash or hang your computer for a very long time. But if you would like to try it, by all means, go for it. But you will not, you'll have to then go to mesh anyway, and it's going to be a very bad mesh to go from pipe to mesh. Whereas with this, if I go to shaded, turn I go to my mesh. Again, this one. So display mesh pictures. Whereas this is very nice, nicely made. Kind of like the topology is very nice. Just box, 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 box. Basically, Houdini is doing the same thing with its wire component, its wire node. don't use the pipe. You won't. It's just not going to work. It's just going to freeze. And we need meshes anyway. So okay, so now you have that, and all right. So let's just say this is meshing. That makes sense. So if you want to change this flow again, like you gotta just do this and just turn that off because it's going to be very annoying to make the mesh pipe every iteration. It's going to be pretty slow. I'm just going to rerun this so that I have only the discrete curves. So we'll just run that once. Okay. And then turn this on. Save this. And turn this on. And there you go. Yeah, so something like that. Let's see. Can I show the parts? Yeah. But also you can download it. Keep that in mind. But yeah, it's like this. But I don't want to take just too much time sitting there. So maybe take a screenshot or something, or just download it. Okay, so remember, turn this off before you run stuff. So we can say, I don't know, wherever we're at, we can say like, you can play with it all day really, but let's just say that this is where we're ending for this part. So all you do is you can come here, like I have a wires layer. I'm just going to bake that into the wires layer. Here, I'm just going to bake it and call that a day. So what I'm going to do is, and also keep in mind, I'm turning everything off when I'm done with it, because I don't want you to open the file and it just goes crazy and everything starts running. So just turn it on. Like if you need it, you just turn this on, and it's a good practice to do this when you're saving a file that someone else is going to use, because you don't want them to just open the file and then like all this stuff happens and you don't know if they have a bad computer. So better to keep everything off until they're ready to use it. Save as. Just let that save, and there we go. So now we have your wires, we have your HD body, right? And it's okay if things come out a bit. That's kind of like the nice, that's kind of the look of it. And you could pull those in even further if you really wanted to, by just the body here. You can do. Just gonna turn this on here real quick. You can do Dendro offsets and you can offset this volume negative. That's the nice thing about the bands that we talked about before in VDB is you can go negative as well. So if I hide this, it's a little too far. Maybe like -1. So you can like create it like a bit smaller than the actual body. This way you're like can more ensure that things stay inside if you wanted. So if I turn on the wires or the HD body, wireframe, you see how like it's in. So you can use that to run the wires in. So that's, you know, you can play with that too. Right now, I honestly don't care. I kind of like when the wires come out like just a little bit. I like that like more, a little bit messier look to it, but I'll leave this in here also. I'll set it to 0 by default. Just have it in here. All right, so I'll just leave that there also. So where are we at? So we're at with, we have wires, we have a body. We have wires, we have a body, and we have joints. And for the ones I was doing, it depends what you want for your look, but the ones I did, I didn't use like the mid body joints because I thought it looked nicer like without them. So that's totally up to you. We just won't export those ones basically when we get to the export, but we have those components. So the next thing that we need to do, like the kind of last Rhino part, is to make these little like features like you see here on the head there. These are like little balls there, little bumps like you see on this face here. So that's the next thing we'll do right now. And then after that, we'll move into some ZBrush and KeyShot. Okay, so let's get those, let's make those ball things there so we can get rid of the HD body, we can hide the wires, we can hide the joints. And what we need to turn on here is just the regular body. Okay. So, and I'm just going to go down here and start like a new something on this next part. So I'm going to get a mesh parameter, and I'm going to set the body part. So in my case, I only want to do the head for like the attractor part, and then like the rest of the body is just random. I thought that looked nice. So whatever I do here, feel free to mix and match and do as you like, but I'm just going to use the head. So I'm going to select the head and set one mesh. So your head should be set in there. And we're going to again do populate geometry. And we'll give it 500 just so it's like got some density. just say let's say head. Okay. All right, so now we have our population geometry. So first thing we're gonna do is we need an attractor, and I have an attractor here. You can use multiple points if you want. I was just using one point. Up to you, and just place it somewhere for now. We can move it around. We'll just set that point in. So point, set point. Okay, point is set, and then do pull point. So pull point is just going to pull from here, from these points to our attractor, and it's going to give us the distance. And the reason I use this instead of distance is because instead of the distance component is because this has this, which is called closest option, which is really nice because you can use multiple points and it'll like figure it out for you. Whereas distance, you'll have to do a lot of like list stuff if you want to use multiple points and whatnot. And also here you can use other geometry too. You can just plug in curves or whatever you want really. So we got to get those distances to be from 0 to 1 for graphs. We're going to use graph mappers so we can reparameterize, which is a pufferfish component. You can also remap, but reparameterize is just quicker. It automatically just goes 0 to 1, and also you can invert it. And so what we'll do now is we'll use graph mappers, and those graph mappers are going to control like the size of, let's say, some spheres on the head. So I'm going to get a graph mapper. What's really interesting about the graph mapper, and I think that also a lot of people don't use, is that you can actually combine graph mappers through multiplication. Like, so, say you wanted a sine wave, but you wanted that sine wave to also have a bit of Perlin noise or something. You can make this Perlin noise, and maybe you wanted to have some better like fall off. You can go to yeah. So, and then all you do is you just like multiply. Oh, zoom in, click add. Right. So now you're kind of like you're combining the effects of all these graphs that we'll use. So you can have a sine wave. Like if you didn't want Perlin, you can have a sine wave, but you can add like a fall off to it. So we'll see what that looks like once we get the values up and running. So now we need to remap that to a bounds, which will equal like the size. Like what's the smallest size sphere we want to have and the biggest size sphere we want to have. So we'll remap. So we'll remap. We'll get the bounds. The bounds is just giving us like this smallest and largest numbers in the set here in the values. So it's 0 to 1.6. So that's the starting range, and we're going to remap it to whatever range we want. So we're going to say construct domain. Now this is where we're going to decide like what's the smallest and largest values that it can be, like we did before with domain. So we could say like maybe we want the spheres to go from like 0.1 to all the way. And basically what we're going to do is we're going to entwine. So this is like another list thing so that you don't have to cull. So we're going to cull patterns, so you don't have to cull with two cull patterns. We're going to take all these points here. Here. So we're going to put all these points in their own list. And Twine basically like puts all the inputs in their own list. Not like a graph like that, but like they'll be in there. You'll see on the output here. See, there's like 3 outputs happening, and then like all those are in that list. And we only need 2, so we'll just subtract 1. And then the other thing we're going to put in the other is the remap numbers. So if I go here, that's not what I wanted. I wanted the true. So basically all you did here was that you just have 2 lists, and one list is the points and the other list is the values, the size values. Just a way to organize them together so that we can do a cull pattern on both lists at the same time, but with one cull pattern component. So I'm going to get a cull pattern. And we're going to cull both those lists with a pattern that's called smaller than. So we're saying like if the number is smaller than the number we define, like get rid of those points and also get rid of those points and also get rid of the values. So yeah, so the value should be, can be, I just make sliders to like tabs. Suspicion is going to be smaller, probably like 1 or something. And then, so that's going to give us a true fall values about the distance. And so there you go. So now those are all the points. So those are all the points that are within this distance, and also, well, within this size range, basically, which also kind of equates to distance as well, because they're attached to this value. So as I move this, so you're basically just calling the points and the radiuses, because these are going to be radiuses for spheres at the same time. That's what you do. Maybe a little bit confusing if you're not so familiar with lists, but that again just takes some practice and is more involved than we have time for here. And now we need to separate them again. So we want to get them. We want to get the point lists and the radius lists like separate, so we can just do different stuff to them. So we do explode tree. And yeah, so now the top will be the points and the bottom will be the radiuses, but they still correspond because we did them together within. So now that we have that, we're going to create a condition where we can invert. And before we do that, actually, I can show you with a mesh sphere kind of where we're at here. Mesh sphere. So these points are going to be the base. So just they're all humongous, right? But the radiuses are going to be from here. Right? So if I hide this body, and just turn it off here, it'll be easier to see. Just want to turn off my preview. So you see how that worked, right? It's like kind of a tractory there. And if you click this, you'll get the opposite direction. So it's like going to be the opposite stuff of the attractor, which is this like where you can flip that. But another thing we want to flip is we want to be able to say like that the stuff closer is bigger and the stuff further away is smaller. So in order to do that, we just can make this kind of flipping condition. So we'll just get bounds again. And we'll deconstruct domain. So we're going to deconstruct the domain. And this is kind of how you flip domains. Deconstruct the domain and then construct a domain with the inverse, right? So then do construct domain and just like cross them like that. Right, so now we went from 1 to 0.9 to 0.98, whatever, to 1. So we just basically reversed or flipped that kind of domain, and we just do remap. And we're going to remap these values to the bounds is going to be the start, and we're going to remap it to the inverse. So now if I were to use that for here for the radius, you can see now you have like the bigger ones towards the attractor. And you can do like we did before if you like. You can do a filter if you wanted to like be able to switch between that for some reason. You could just do it like this. Put a boolean here. And that will let you switch between like the two conditions there. So this one switches between like bigger, closer, or smaller, closer. And then this one here lets you switch between like which part is getting taken away. And you can do some stuff like you can put this like offset like that. And like I mentioned, you could potentially do like if I just copy this point and set them both in here, you could have both of them doing stuff too. So really whatever you want, and you can have more more points if you want it to feel like more like dense. Pretty cool. And then you can play with these graphs. So like graphs, like for instance, if you do a sine wave here, let me try to make this. So you can use the graphs. Like if you wanted to have more like a sine effect, so you can do some kind of like weird stuff with that. Could be something like that, but then you can also add like some Perlin noise to it. So it's going to give like a bit of randomness even in there, even though it is a sine wave. And maybe you want it to like fall off, like so the sine wave should kind of fall off to the sine wave. So yeah, I don't know. Maybe I'll just do something like that. It's kind of interesting for now. So yeah, you play with all those values. So that's all you need for this, like these parts. So I just put those as part of the bumps layer. So I'm just going to bake those onto our bumps layer. So let's see. This is more like density. Let's see. And then this is like up to here. This is all like tractor. Tractor. Sometimes it won't show up from the group for some reason. We'll say this is the tractors. And then we have this part here, which is about remove by distance. And then we have this part here, which is about inverting size. Size, and then yeah, finally okay, so that's that for that part there. And also, actually, you could let me just to make a point, you could also use curves, or you can do a mix of curves and points too if you wanted. If you wanted to use a curve for some reason, I could turn on the body and I can just draw a curve somewhere. So I want to use that. So you can do stuff like that too. Use curves. Maybe I would use that instead. Just like put that on the attractors layer. So you can plug in any of these, or both of them. If you do both, you'll consider both. But I'll just keep it for now. Let's just do that for the bumps. Okay. So that's this part here. So now we have our like head bumps. Let's see what's next. Oh, last part is like this simple part that's just like these random bumps on like the rest of the body, which is pretty simple. So just get a mesh. And we are going, I use only certain meshes. Like I use the arm, I didn't use the hands or the fingers because it got a little weird. And then I just used like the legs, like these parts, and just set those in. Set multiple. And we'll just go to, we'll just go and we'll set this as other body parts. Okay, so you have other body parts, and so we'll again join it all together as one. We'll do again a populate geometry and choose a number to populate. And we'll just make a random component. And the number of random should be the number of points we have. That's how many random values we want. And we just get, again, a construct domain. And then we'll just determine like what's the size that we want to play within. Can be anything that you want it to be. And then you just do mesh sphere again. And got like a fat suit there. We don't want that. And then we want just like small little details, which is what you were seeing here. Like you can see there's like the head, and then there's just these small little ones all around the body. Around. Oh, the other thing actually I forgot to do up here is, because again we want like nice reflections, so I'm actually gonna delete these. So we're just gonna do, I'm just gonna do 20 for UV, 20 divisions, just so it's a bit more divided, a bit more smooth. And we'll do the same down here. So this is going to be just random colors. And we'll just bake those to the same layer bumps because they'll be the same material. So it's like that. And then we'll get rid of our body, and we'll just want to turn on the things that we want to export. Save. Yeah, so we can see what we have so far. Looking good. I think it's going to be a pretty interesting one. So the next stuff we're going to do is the ZBrush and KeyShots, and we should finish on time, maybe a little bit longer, but should be good. So let's take a little bit more of a break. We've been kind of powering through this. Let's take a 10-minute break. Files are saved if you need. download them. If you are behind or need help, yeah, just download them. And actually, I don't think I ever saved this Maya file. I don't think somewhere around. Send a download link. Sure. Okay, no changes to say. Yeah, download link. Link. Okay. And just thanks. Yeah, we still got a bit more to go. And yeah, guys, remember, while we're on break, feel free to take screenshots of my screen or your screens or any screens and tag, and so we can share and see and share it around here. So yeah, okay, I'll be back in 10 minutes. See you. Okay, I'm back. We're exporting more things than just the wires and spheres. We'll go over that now. All right, so at this point, we're done with Grasshopper. Save more time. And what we want to do now is we want to export, and I'll export it in Rhino here. So first we can export all the parts. Y'all could still see my screen, yeah? Anyone could acknowledge that they're seeing the screen and everything. Anyone there? Okay. Cool. So we're going to export the parts we need. So we're going to need the wires, obviously. So just do select objects from the layer, and then just do file, export selected, and I'm just going to export it to I'm just going to export it to my desktop just for so it's fast, and then I'll just put it in this folder for you guys too. So OBJ, I'm going to export OBJs, and I'm just going to keep the names the same. So wires, I'm just going to keep them the same as the layers I had in Rhino. So wires, polygon mesh objects, everything should be fine. Yeah. And, yeah, everything should be map Rhino Z object Y. Should be okay. We'll find out. Okay, so geometry, polygon mesh objects, and go. Okay, so exporting the wires, and if you need, I'm just going to put them in here. So wires. We need the bumps. So select objects, export selected, bumps. And we want the joints. Now the joints depends on you. I preferred to not use these ones, or these like hip ones here, because I thought it just looked better. So basically, I'm just gonna select objects, and then with Control and click, I'm just gonna deselect these. So I'm not gonna export those. I'm just gonna export these ones here, the fingers and all that stuff. If you want to use other ones, then just export them as well. Selected. We already have a joints there. So let me get ones that we brought in here. So, maybe it's easier if I just in here. Okay. And we need the HD body. So not the body we've been using Grasshopper, we want the HD body. So select that. File, export selected. And just make it body HD. Got it there. Okay, so those are the 4 things we should export: the HD, the body HD, the bumps, the joints, and the wires. Okay, so now we have that. Let me just check something here. Just check something. So now we're going to open ZBrush. So open your ZBrush here. And what we do in ZBrush, we're just going to be messing with the wires. We're not going to be messing with the other stuff. The other stuff is as it should be. So I'm just going to go to import. Just go to your wires OBJ and open it. So once you open it, basically what you do is you left click and drag, and you'll see it come onto the screen here. Not sure why it looks so weird. Let me check my resolution. But then once you do that, you just click edit, and that will put you in edit mode. So don't miss that step. And let me just check why my thing looks so weird here. I'm just going to reopen ZBrush, and something weird going on with my file there. So I'll just reopen it. I had it open like all day, so who knows what happened. So, ZBrush. And just as before, I'll be working in the ZBrush file that's in the Dropbox. Size. Then documents. I just doubled my document size because I'm working on a pretty big screen. I think that's why it looked like weird resolution. So. All right, so import and the wires. And then click, drag. There we go. More blurry. And then first thing you do is go up here and you click edit. Right, so that's gonna let this be so you can stop creating like more, let it be editable. And so in ZBrush, you just left click to rotate, and then Alt and left click to pan. And then even weirder is Alt and left click, and then let go of Alt to zoom. Very annoying, but it is what it is. So we have these wires, and what we want to do is like kind of smooth them together. And a pretty easy way we can do that is with ZBrush. If you go over here to geometry and you go to Dynamesh, and I'm just gonna, this is resolution 128. I'm just gonna click it so you see what happens, and you see it's like became like this kind of mess. But we want more resolution than that. So what I'm gonna do is bump this up so we can see what this 300 look like. So you just click there, type a number, hit enter, and then Dynamesh. Still want more resolution, so I'm gonna try 600, enter, and then Dynamesh. So that's starting to look like the kind of gooiness that I had in mind. Right, so and you can see it's very quick with ZBrush. That's what's really nice about it. And then what we want to do is like go over it like with a bit of smoothing. But to smooth things, ZBrush, you hold down Shift. If you hold down Shift, you'll see my thing turns like blue. My circle there, it turns blue. That means you're in smoothing mode and you hold on Shift. So if you hold on Shift and then left click and drag, you see how it smooths, but it's smoothing too much. Unless that's what look you're going for, then do that. But we wanted to smooth it less. So two things we can do is while holding Shift, we can come up here to the intensity and we can lower the intensity so it will smooth less like that. But also we want this thing, like I don't like that I can see the kind of resolution of the mesh. Like I don't like that I can see the jaggedness of it. So all you got to do is just go here to divide and just give it more subdivisions. So you can go one more, and if you're daring, you can go even another, and then smooth it, and you'll see like you don't see much change, but the mesh is actually like if I zoom in, the mesh is actually getting smoother. So we're just gonna and you just go over it, like just polish it up like I'm doing here, just to give it a little bit of smoothness and getting rid of some of that bumpiness. It depends how much bumpiness you like want to see, really. Like so if I look at this leg here, like you can see this kind of like ripply. If I do this a bit, you see it like kind of smooths out a bit, which is nice. So we're gonna just smooth some of that stuff out. So once you've gone over it a bit, so it looks like how you want it to look. The other thing you can do, we're mainly just using ZBrush for that, but another thing you can do is if you go over here to the brushes and just click it and then go to just press I, you'll see this inflate brush. So this inflate brush is pretty cool because you can thicken things. So maybe you wanted this area to be more smooth together. You can use the inflate brush and like get it bigger, and then you can bring it down. You can really play with that, and then you can just do Dynamesh again at the same resolution. You have to delete. So delete the lower here, delete lower, and then Dynamesh it. And yeah, so you see it like kind of pull out together, and then you can smooth that out if you want like some area to be like thicker and something like that. So, that's not a thing you can do, but I'm just gonna go back to if you see up top here, there's like this kind of like history timeline you can go through. So I'm just gonna go back to like so up to you, like if you want to like make things puffier or less puffy, but I'm kind of okay with where this is at right now for the sake of Yeah, yeah, it does do that. Yeah, control. If you do it off of the mesh, it will redo the mesh with the control left rectangle selection. So that's really all I'm using ZBrush for, is like this kind of like remeshing and smoothing, because it's just like really fast at it, and it gives you this kind of aesthetic that I like. So then we're just going to export this now. So actually, first let me save this. So and I'll just replace it in our shared folder here. And so then you'll just export this, export, and I was just name this whatever you want. I was naming it like goo. So just save obj. Okay, and I'm gonna put that in our shared ZBrush, because it's from ZBrush, the output, obj output. Okay, so we did that. So that's really all. That's really it for the ZBrush part. Simple stuff. So next, now that you have all your parts, what we're going to do is we're going to open KeyShot. And, okay, so my image size is square. It's up to you how you want your image size to be. If you don't see any windows, right, you just go to Window and Library, and you can just like select them, like materials. Like if it's missing like that, just go to Windows, Library, Materials, and then this one here is like Windows, Library. What's that one called? It's model. Project. So go to Window, Project, Scene if you don't have that side thing. So just Window, Project, and Scene, and don't have that. So okay, so now what we're gonna do is we're gonna bring our we're gonna bring our stuff in here into KeyShot. So let's open our folder here. And we could bring in the GUI stuff there. So I just like drag and drop it in. You want to make sure keep position relative to native is on. And you want the up orientation to be Y, because we were exporting from Maya like Y to Z, and then Rhino Z to Y. So just make sure up orientation is Y in this case. Otherwise, you're going to have to rotate the model. And just always keep position relative to native origin. We don't want to center the geometry, because then everything's going to go on its own center, and it's going to be, and we don't want to snap to the ground either, because then everything's not going to align when you bring it in. And yeah, and then just import, and just give it a few and let it get in there. And now if you come in and you can't find your model, just select it here, and go center and fit part. So that's going to center and fit the camera. So like that, and then you can find your character there. So there's our goo there. If you want to change the size of your thing, you notice mine's like a square setup for Instagram. You just go here to image, and you can change the width and height of the image of this screen here. So if I change this to like 1,000, see it's going to get like taller than it is. So I'll just keep it as a square for now. Okay, so let's bring in our other stuff. So let's go here to our folder. And I'm going to go back to the Rhino Grasshopper stuff. And I'm going to go to Object. And I'm going to bring in the other stuff. I'm going to bring in the wires. I'm going to bring the wires before we change them. I'm going to bring in the joints. HD body. Oh, what happened there? Must have messed up my selection. Let me redo that. That's it. Yeah. That's weird. You know what I think happened was I think I dragged it into Dropbox before it was done being made, before it was done exporting, so it was only like half of the body. So back here. Okay, now let's put that back in. There we go. And lastly, we need our bumps. Okay, so we have everything we need. So the first thing to know is that we want to, if you have a decent computer, you'll want to use GPU and denoise. It'll make things a lot faster, especially if you want to mess with like subsurface materials like the and glassy materials with like reflections. You can just see how there's like a lot of grain there still for a long time. But if you go into like GPU, denoise, it's gone like immediately. So it's a lot quicker. So want to make sure if you have a GPU that's compatible, make sure to use those and things will be a lot quicker. So the next thing we need to do is I'm just going to turn the thing off right now, except for the body, the HD body. So the next thing is we want to make sure if we want to get like these kind of nice reflections, what we can do is we want to do an environment. And so if you go to environments and environments, there's like these environments, these HDRIs that you want to use these kind of things so you get these nice reflections in the transparency. And obviously we don't want to see like the background, right? We just care about like the lighting. Like you see how much better the lighting is on the character when you add these HDRIs. material. And so then we'll just go to the environment and we'll just, we can just pick like a color for the, no, I was using black. I think black looks good for this Halloween things. But you can see how much nicer like the reflections look just by adding something like that. And we can start making the materials. So I'm just gonna, now that we've changed that, the first thing we'll look at is we can look at the goo layer. I was using materials that you can find in, for instance, where is it? Translucency. So they're like more like skinish layers, but they're very slow on without GPU modes. Right. So if I zoom into this, you can see it's like you got like this kind of subsurface scattering. It's called. It's kind of looks like wax or something. So you get those that wax in there. And what really brings this out nicely is what I do is I take the wires, so put the wires on and turn the glue off for now. And for the wires, we'll give it some kind of like black material. So we can go to like, we can look at like metals, maybe like a metal brushed black or something. And when you have them both on, what you'll do is just zoom in a bit and select the wires layer by just selecting it here in the menu and right click and go to move selection. And what you want to do is you want to just like nudge the wires around a bit so they're just like a bit offset. Right. And then you'll, once you find like the right kind of, which looks like good to you, you can go like back and you can go like here down to something. That's how you start to get like this kind of like mixed look between the two things there, which I think is quite nice. And again, it just really depends like how much you want to exaggerate it, and all these things change. Like I think, you know, for these ones here, as you can see, I was using a lot denser amount of like points and trails. But again, like when you're doing something live, we don't really have time to wait for those things to finish. So just get like a, you know, if you want more or less, you just make denser or denser amount of points or less, more dense amount of points. And we can even change this, like, so if you come down here, if you go to materials and we select this translucent, we can change the color a bit, like if we want it to be more. And we can also change the translucency amount. Just all depends like what kind of like look you're going for in your creature there. Actually, I'm just trying to remember. Yeah, I did black there. But you can rotate the lighting too. So if we go to the lighting here, this rotation. There we go. That's better. The light was kind of like on the back side. That's why it was looking so dark. So you can just rotate the lighting around. Okay. And you can do things like adjust like generally like the brightness if you wanted to, or something. If you want it to be more bright, just so it's easier to see, probably on the screen here. So you play with those things, and then what we'll do is we'll turn on the body. And so for the body, what I did was I used like, if you go to translucence, or not translucent, sorry, miscellaneous, there's like these soap textures. So I use this soap bubble. And the soap bubble by default is like kind of colorful, which you might want. But if you go to material and then go to the soap bubble, just double click it, you can play with like the thickness of it. And so if you change the thickness and the refraction, you can get rid of that color and just kind of be left with like a very faint bubble with reflections, which I kind of like. That's what I did for the promo material. Right, so that's looking kind of pretty sweet, I think. It's kind of like gross actually, which is kind of cool. I like how it like goes into this horn here. And then what you'll do is the last part is you'll get sorry, two more points. You got the joints. So with the joints, what I did was I just used like a glass, and I used glass light frost. I think I used glass heavy frost for the joints. Yeah. Now again, if you like these heavy frost and subsurface like scatter materials can take a while to render if you don't have a good GPU with a denoiser. So then you have that, and what I did was I went to the here, and you could change like the color of the glass, and I gave it like a bit of an orange tint. I'm gonna do that, and you can play with transparency and all that stuff. And then last is the bumps, right? And the bumps, I used the same material as the joints. So you can actually just go to material and drag the one that you've just changed for glass and use that also for the joints. And that's, in terms of like materials, that's basically what I use, but you feel free to explore any materials you like. And then what I did is, the last kind of like icing on the cake there is to find a view that you like maybe something like this. And things always look creepier when you're looking at them like these kind of like monsters when you're looking at them from like below. So I was just like kind of doing these like more lower angles. And then what you want to do is you want to bring some of this detail out, and the way to do that is with zoom in a bit. Then what you want to do is you want to just get go to camera, and you want to go to depth of field, and just turn that on, and it's going to like look like that. But then you just click this button here, and you can select like the focal point. And I like to select like things closer, so I might select like around this arm area, something like here, right? So now you see how clear the arm became. But then you just got to play with the f-stop so that we can start to see back behind that arm. So just play with this number until it looks the way you want it to look. Like this is even kind of creepy too, like just seeing the hand and then like everything else kind of blurry. But we might want to go like something like 100 or something, just so we can actually see the thing. 100's maybe too much. Kind of wants to hold it there. Maybe something like this, where something's close and then other things are a little bit blurry in the background. This is always kind of interesting. And that's it. that's basically all there is to it. Those just combining those tools. And just playing with, you can play with the lighting, play with changing the rotation of the lighting. We don't need ground shadows in this case because we're not rendering the ground. It's just want to change the now. Just want to put it like kind of want to see a bit of the weird skinny torso there. And you can also change the lighting environment, like from basic, you can go to like products. Product sometimes looks really good. Interior. So you can change those as well. Change the lighting a bit. So you see as I change the lighting, like the reflections are moving around as I rotate. And now it became like, see, it became like darker. So just play with that lighting until you get like the right lighting that you want. Like just rotate that around. You can also add lights like in KeyShot, but I don't usually like mess too much with light adding. So yeah, maybe we'll play with this a bit more. I'm glad you're all having so much fun here. Yeah, so and then once you have like what you like, you just once you have something you like, something that you can do is you can go to camera and just do like this, add camera, and then like lock it so that you don't lose that view. So you can go back to free camera and you can find another view, like maybe this view is kind of cool too. And that camera also will save, that camera will also save the depth of field setting that you put for that camera. So you don't have to keep resetting it each time like you switch to the other views. So once you're in a new camera, you can do again, just do that. And then if you lock it, you won't be able to play with depth of field. So you just unlock it, and then we want to change the depth of field for this one, right? So just click this again and select, maybe it's like at this elbow here, just to give it a bit, and things can be a bit further away. So like 25 maybe, just to get some blurriness back there, and the arm back there. So I'll save this one. So since that unsaved, so you just click save and then lock it. So again, like I can go back to camera 1, camera 2, and maybe you want to do like a like a detail, like I was doing those kind of close-up shots. Maybe you want to find some interesting moments to get a close-up of. Just turn the fill up for a second, just so I can see. you want something close like that, let's say. And then again, just camera, and then adjust the depth of field if you want to use depth of field. Put it to like the shoulder or something. And change this again to the 50. Maybe more 75. But the reflections look really nice on this like smooth body, so that's good. Yeah, so like say you like that, and then you just do the same. You just do save and then lock it. So now you have these 3 views, and you can just like render them. Where's my chat? Yeah, I lost my chat for a second. And yeah, so now if you want to render this out, you go render, and you can do a screenshot if you want to do just a screenshot of what's on the screen. Or you can do render and like this, and you can just do, you pick your render size. So I always tend to do a resolution double the size of my intended image, just so I have high resolution. So this is 1280, so I'm rendering it 2560. So just double. I double it. 150 is usually enough. The important thing is also in options, you want to make sure render engine inherit from real-time view. So this way, if you're in GPU mode, it renders with the GPU. If you're in CPU mode, it renders with the CPU. And to get those nice, like to get rid of all that grain, like in the foggy materials and cloudy materials and subsurface scattered materials, you want to have a good amount of samples. So I usually bump it up to like 250. And then, yeah, then you can just render this thing. So you just click render and let it go, and it will, again, but I'm on a very, very fast computer right now, so this will take like not that long at all. Usually even faster than this, but I have like 10,000 softwares and Zoom open at the same time. But yeah, so you know, just hit render and you let it render, and it won't be like this for this one. So because I have denoiser on, so I don't know if any of you are using denoiser, but it's really quite good. That will render. And yeah, that's it. So now I'll just open the rendering so you can see. And there you go. Beautiful, professional quality render that we can, I mean, we're purposely blurring that, but the image is not blurry. It's pretty high resolution. There you go. That's how it goes. I kind of like actually that this one like accidentally somehow had a mouth, which I thought was kind of funny. You saw we just did this live. Like I don't know how that happened, but it's kind of interesting. And yeah, so when you want to render other stuff, just repeats. So just this is saying it's done, and then just switch to your other, go to camera, switch to your other views, and render, let go, and good to go. So, anyone has any questions? My specs are it's a RTX 3090 AMD Threadripper, and I think 128 gigabytes of RAM. How to remove free version watermark? Pay for it, I guess. um, yeah, so this one finished. So, yes. So let's check out that one. So like it's, yeah, it's pretty cool, I think. Can you save your version? Yeah, I'll save it now. I just want to render while we're here. I just want to render the and I'll save also these three images there too. As a reference. Yeah, so I hope you all enjoyed it. Seemed you did. It was a lot of fun for me to come up with this workflow. And remember, follow and tag. Show us your monsters. Will you share all the files? They're already shared. I mean, I've been saving them to that Dropbox the entire time. They're already there. The files are all already in the Dropbox. The recordings will not be in the Dropbox. No, they'll be emailed. Oh yeah, and that's another thing. Everyone that's attended live, the recording will also be downloadable. So you'll be able to download it and keep it. But you'll only be able to download it for 2 months. So download it before the 2 months. Otherwise, we get rid of it from the server. This one's taking out a little bit longer because it's closer, and also I just have so many things running right now. So after this one renders, I'll just put all this stuff in the Dropbox, and we'll let you get on with your day there, day or night. Okay, that one finished. Let's check it out. Oh yeah, that looks nice. Cool. All right, let me save this KeyShot file. Okay, and so actually, so if anyone does have a good GPU and denoiser, just turn it on when you open the file. I'm going to save it with them off because if someone doesn't have GPU and they open it, it's going to cause a bunch of issues, like if it's set on while saved. So I'm just going to save it. And just check that it's saved in the right place. Yeah, just it. It's cool. Trying to smile at this point. Account to make it rigged. No, I haven't. It's because I know what will happen if I try to make it. Yeah. It won't. You'll definitely have to reduce it and do some kind of like texture mapping tricks. It would be way too heavy. So let me put these in here too. If you want to just have them as a reference. Yeah, so okay, so everything is in the Dropbox now. So you can download everything, and recording will be emailed. Will likely be my time tonight or tomorrow morning. It usually takes a couple hours to send to for Zoom to process it. If anyone wants to take any screenshots, feel free to do now while it's open. So I hope you all had fun. I had fun. So and look forward to the next one. We used Maya in the very beginning. We used Maya. We went from Mixamo to Maya to Rhino, Grasshopper, then to ZBrush, then to KeyShot. So maybe you missed the beginning of the webinar. No worries. You'll have it in the recording. Okay, so thank you all. I'll see you. And yeah, send us your monsters. The Chinese model file. Oh yeah, answer that. You're welcome. Bye all. Have a good Halloween.